Hello everyone, I am Balaji Rao. Welcome to BR Maths class. Now you can join in the batch JEE 2026. The course link is given in the description. We are doing basic mathematics. We are doing basic mathematics chapter. In that, till now we completed two topics, number system and algebraic identities completed. In this class, you are going to learn about inequalities. See, this number system chapter, algebraic identities, you already learned in 10th standard. I suppose that you are doing this inequalities chapter first time. As you are doing this inequalities chapter first time, I'll guide you clearly what way to learn this chapter, right? How to learn this inequalities chapter. First point, how important this chapter is. This chapter is very important. Inequalities linked in so many other chapters. Functions chapter, inequalities will use. Matrices chapter, inequalities will use. Inequalities chapter, whenever possible, we can use. That's why learning this chapter is very important. Right? How to learn this chapter? Total 5 points are there. First point, learn about symbols in this inequalities. These you already know, less than, greater than, less than or equal to, greater than or equal to. And learn about intervals. This I think you didn't learn in 10th standard. Closed interval a comma b, open interval a comma b. Learn about intervals clearly. After learning about intervals, what is meant by union of intervals? Intersection of intervals, all those things learn clearly. After that, in this chapter, three golden rules are there. Complete chapter runs on these three rules only. Understand those rules clearly and practice decent number of problems. I try to cover maximum number of models based on these three rules, right? So be good in these two things first. Do not show any hurry to do JEE problems related to inequalities. First, learn basics. Zero to hero. You are doing this chapter first time. Learn the basics properly. Okay. After that, there is a method called wavy curve method. This method is not in NCERT textbook, but very useful, very helpful, right? In this wavy curve method, total 4 types are there. Understand what is wavy curve method. Suppose what is rational inequality, inequalities involving with quadratic expressions. Total 4 types are there. I did all the problems type wise. Type 1 problems at one place, type 2 problems at one place, type 3 problems at one place. I given detailed explanation considering that you are doing this inequalities chapter first time. Once these 3 things are over, then previous year questions. I checked previous year questions from inequalities. Very less I find, because this inequalities chapter, we use this inequality symbols we use frequently in functions chapter, especially including modulus function, including logarithm. So I felt that it's not a good idea to confuse you by explaining modulus function inequalities, logarithmic function inequalities, all those things. However, I'll discuss all those things in functions chapter. But right now, those things are not needed, right? However, whatever possible PYQs are there, based on these things, I covered those things. After that, material, whatever the material you will get from your college or your coaching center, DPPs, whatever they'll give, you practice, right? That much is enough. Don't make the things complicated. Keep it simple, right? Next, quality and quantity. Quality is important. See, how many problems you did, that is not important. From inequalities chapter, I did 200 questions, but didn't learn anything. No use. Quality. While solving the problem, if you didn't get the answer, you consider that there is an opportunity to learn from that question. Why I didn't get the answer? What point I missed? Right? Quality is important, not quantity. In intervals, total 4 types of intervals are there. We'll see one after another what are those intervals. You observe this. This is first interval. How you read this interval? We read this interval as closed interval a comma b. Whenever you see this type of brackets, you see these brackets are known as closed brackets. So how you read this interval? We read it as closed interval a comma b. Somewhere you saw like this, closed interval 1 comma 2. You read it as closed interval 1 comma 2. Okay. What it mean? Closed interval a comma b means what? Look here. Closed interval a comma b contains all real numbers between a and b. Closed interval a comma b contains all real numbers between a and b, including both a and b. This I'll try to explain on the number line. We'll take one example to understand this. I'll take example the closed interval 1 comma 3. How you read this? We read it as closed interval 1 comma 3. Closed interval 1 comma 3 means what? It contains all real numbers in between 1 and 3, including both 1 and 3. I'll mark this closed interval on this number line. See here first 1 is there. You write a dark circle. That means here this is closed interval. Na? Closed interval means 1 is also included, 3 is also included. That's why I'm marking a dark circle here. Okay. Here one dark circle. At 3 also you mark one dark circle. Okay. At 3 also you mark one dark circle. Why this dark circle here? Because this is closed bracket. This is closed bracket. Okay. Now you mark all the things in between these two. Right. See here. This, you see this blue color part is there. Na? What is this? This is the closed interval 1 comma 3. Whatever numbers present in this, that are present in this interval. This interval is closed interval 1 comma 3. For example, in this interval 1.9 is there. You see here in this part 1.9 is there. 1.9 is there. Yes, 1.9 will be present somewhere here. Yes, 1.9 is present. So that means 1.9 is in this interval. For example, 0.5. 0.5 is not on this part. Not on this part. 0.5 does not belongs to this interval. I hope you are understanding. Closed interval 1 comma 3 means what? Closed interval 1 comma 3 contains all real numbers between 1 and 3, including both 1 and 3. Now, a small question to you. See, this is closed interval 1 comma 3. In this interval, 1 is there? Yes, that's why here this dark circle is there. In this interval, 1 is there. In this interval, 1.00001 is there in this interval? Yes, all real numbers in between 1 and 3, including both 1 and 3, are present in this interval. See, in this interval, 2.999999. This number is present in this interval. Yes, 2.999 somewhere here. This number present in this interval. 3. 3 is present in this interval. Yes, because this is closed interval. Na? In closed interval, 1 is also included, 3 is also included. 3 is belongs to this interval. 3 is present in this interval. I hope you are understanding. Closed interval 1 comma 3 contains all the real numbers between 1 and 3, including both 1 and 3. For example, another example I'll take. The closed interval, how to read this, that also you need to understand. The closed interval 1 by 2 comma 4. Something is like this. What this interval contains? Closed interval 1 by 2 comma 4. You mark this on the number line. See here 1 by 2. 1 by 2 means what? 0.5. Where is 0.5? Here 0.5 will be there. So here this is closed interval. Na? At 0.5 you draw the dark circle because it is closed interval. This is 1 by 2. 2, 4. 4 is here, right? You mark one dark circle here, 4. We are writing dark circle means that point is included. Now join. See, whatever numbers are present in this part, in this blue color part, all the numbers present in this interval. I hope you are understanding. In this interval, 0.4 is there? No. This interval starts from 0.5, 0.4 somewhere here. In this interval, 0.4 does not belongs to this interval, right? In this interval, 3 is there? Yes, 3 is present. In this interval, 4.001 is present in this interval? No, right? So this is closed interval 1 by 2 comma 4. What it contains? It contains all the real numbers between 1 by 2 to 4 on the number line, right? Now I want you to mark this on the number line minus 2 comma 3. You please mark this part on the number line. Okay, if you mark it, how it comes, this is closed interval, na? It means minus 2 is also included, 3 is also included. See, you join them. See, this part, this red color part is there, na? This part is what? This part is the closed interval minus 2 comma 3. So you are learning about intervals. In the intervals, first one is the closed interval a comma b. How you read it as? You read it as closed interval a comma b. Now we'll move to second one. You observe the second one. Second one is this. What is this? This is open interval a comma b. You see this here, you observe the brackets. See, these are like this. Whenever brackets are like this, we call it as closed interval a comma b. Whenever brackets are like this, we call it as open interval a comma b. I hope you are understanding the difference. This is closed interval a comma b. This is open interval a comma b. Okay. See here, this is open interval a comma b. How we read it as means? We read it as open interval a comma b. You observe here, what is this interval? How we read it as? We read it as open interval a comma b. This is open interval a comma b. Open interval a comma b contains all real numbers between a and b, excluding both a and b. So what is the difference of closed interval a comma b and open interval a comma b? Closed interval a comma b also contains all real numbers between a and b. You see here, closed interval a comma b. See this closed interval a comma b contains all real numbers between a and b, including both a and b, right? Here, this is open interval a comma b. This is also contains all real numbers between a and b. In open interval, we'll exclude both a and b. In a closed interval, we'll include both a and b. That is the difference, right? So, okay. Open interval a comma b contains all real numbers between a and b, excluding both a and b. We'll try to understand this. Here, I'll mark the interval. How we read it as? How we read it as? We read it as open interval minus 1 comma 2. What it contains? Open interval minus 1 comma 2 contains all real numbers between minus 1 and 2, excluding both minus 1 and 2. Here, minus 1 is not in this interval. Minus 1 is not in this interval. So, how we will mark this on the number line? As minus 1 is not in this interval, at minus 1, you draw open circle. It indicates minus 1 is not included. Okay. So here you observe, I am drawing like this. Earlier we drawn it as a dark circle. In this interval 2 is present? No. We are excluding both 1 and minus 1 and 2. Okay. So at 2 also you draw one open circle. Okay. Now see this part is there, this blue color part. You observe here all the real numbers in between minus 1 and 2. These both minus 1, 2 are not included. Okay. So now my question is, in this interval, minus 0.5 is there, minus 0.5. You see here, minus 0. Somewhere will be here on the number line, minus 0.5. Yes, minus 0.5 belongs to this interval. In this interval, minus 0.99999 is there in this interval? Yes, minus 0.999 will come somewhere here, right? So that is in this interval. Now, in this interval, minus 1 is present. In this interval, minus 1 is present. No, both these two numbers are excluded. Minus 1 is excluded, 2 is also excluded. So, minus 1, see here, minus 1 does not belongs to this interval, open interval, minus 1 comma 2. This symbol is belong symbol. See, minus 1 does not belongs to this interval. Is 2 belongs to this interval? 2 is present in this interval? No, 2 is also does not belongs to this interval. Then what are present in this interval? All the real numbers between minus 1 and 2, excluding both minus 1 and 2. I hope you understand. First one is what? First one is the closed interval a comma b. Second one is what? Second one is open interval a comma b. Now we'll learn about this third one. What is this third one? See this third one. Observe this third one. What is this? You see here bracket is what? Closed bracket is there. Here open bracket is there. How we read this interval? How we read this interval? Look here. The interval closed A. This side closed bracket is then the interval closed A open V. How you read this interval? The interval closed A open V. We read it as the interval closed A open V. What it mean? What it contains? You observe. What is this? How you read it as? The interval closed A open B contains all real numbers between A and B. The interval closed A open B contains all real numbers between A and B. You see this dialogue is common in all these intervals. Contains all real numbers between A and B. Here closed interval is there. That's why between A and B including A. We are including A. A is present in this interval but excluding B. Right? Whenever closed bracket is there, that particular number is included. Whenever open bracket is there, that particular number is excluded. So how you read it as? You read it as the interval closed A open B. It contains all real numbers between A and B. It contains all real numbers between A and B, including A, excluding B. We will try to understand this on the number line. Okay. You observe this. How you read it as the interval closed 0 open 3, right? What it contains? Interval closed 0 open 3 contains all real numbers between 0 and 3. 0 is included, 3 is excluded. Okay, so how you mark this on the number line? See, 0 is included. Na? At 0 you draw the dark circle that indicates that 0 is included. See, 3 is not included because this is open 3. So at 3, you draw one open circle like this. It indicates that this point is not a part of the solution. Okay. Now you observe this part is there, na? Blue color part. That part is, what is this part? The interval closed 0 open 3. The interval closed 0 open 3 contains all the real numbers between 0 and 3. 0 is included, 3 is excluded. In this interval closed 0 open 3, 0 is present? Yes. You observe the interval closed 0 open 3. In this interval 0 is present? Yes, 0 is present. In this interval 3 is present? No. In this interval 3 is not present. In this interval 0.99 is present? Yes, 0.99 somewhere present here. Yes, 0.99 is present here. In this interval 2.999 is present in this interval? Yes, 2.999 is present in this interval. In this interval 3.01 is present? No. This doesn't contains the number. This interval does not contains the number 3.01. I hope you are understanding. Now see this fourth one. What is this fourth one? How you read it as? Now you are able to read this. How you read it as? The interval. See a bracket here. The interval open A, comma closed B. How you read it as? The interval open A, closed B. This is the interval open A, closed B. You see here how you read it? The interval open A, closed B contains all the real numbers between A and B, excluding A and including B. See, excluding A. You can observe here at A, open bracket is there. See here, excluding A. Whenever open bracket is there, that is excluding A. Here, including B. I'll explain this on the number line. You see this interval, how you read it as? Interval open -2 closed 1. You need to mark this on the number line. See here, open -2. Open -2 means minus 2 is not included. So you just draw one open circle like this. 1 is included, this is closed one. 1 is included. At 1, you just mark one dark circle. Now, what numbers present in this interval means all the real numbers. All the real numbers in between minus 2 and 1 are present in this interval. Minus 2 is excluded. 1 is included. So, I hope you understand all these four types of intervals, right? So, what is the first interval? By seeing this interval, you need to know first how we read this. We read it as closed interval a comma b. How we read it as? We read it as open interval a comma b. How we read it as? We read it as the interval closed a open b. How we read it as? We read it as the interval open a closed b. You observe here, if you see this type of notation, x belongs to closed interval 1 comma 3, then this can be written like this. Here, this is closed interval 1 comma 3. Na? So, then this can be written as 1 less than or equal to x less than or equal to 3. So, when x belongs to this interval, it means that x values lies in this interval including both 1 and 3. This can be written like this. It indicates that x value lies in between 1 and 3. Here, less than or equal to indicates that 1 is included. Here also equality symbol indicates that this 3 is included. So x belongs to closed interval 1 comma 3 means this can be written as 1 less than or equal to x less than or equal to 3. Similarly, you see here, if you saw this notation, x belongs to open interval minus 1 comma 2. How we write this? We write like this. Here it is open interval. In this minus 1 is not included. So we write it as minus 1 strictly less than x strictly less than 2. If x belongs to this interval, then we'll write like this. This indicates that x lies in between minus 1 and 2. Minus 1 is not included. 2 is also not included. Similarly, when you see this type of notation, x belongs to closed 0, open 3. How we write this in interval form? How we write this? We write like this. Here, closed 0 is there. That means 0 is included. When 0 is included, we will write less than or equal to. When closed bracket is there, this equality symbol will come. X less than. You see, this is not closed bracket. Here 3 is not included in this interval. So we write like this. So whenever you see such type of things, we'll write like this. 0 less than or equal to x strictly less than 3. Okay. Similarly, you see here x belongs to open interval minus 2 closed 1. How we write this in symbolic form? You answer how we'll write this. Which side is less than symbol, which side is less than or equal to. Here open bracket is there here. So what we'll write? Minus 2 is strictly less than x less than or equal to 1. I hope you are understand. So whenever x is in this interval, then we can write like this. So you learn all four types of intervals. Now we'll come to the difference between equation and inequality. What is the difference between equation and inequalities? First, what is equation? What is equation? Between two numbers or two algebraic quantities, if we use the symbol equal, then that will form an equation. For example, two algebraic quantities I'll take. See 2x and 5. Two quantities I taken. If I use the symbol to relate them, if I use the symbol equal to relate them, then what this forms? 2x equal to 5 is an equation. So generally what happens in equation, two quantities will be there. One is left hand side, another one is right hand side. If these two are related with the symbol equal, then what this forms? This forms an equation. For example, x square plus 2x plus 5 equal to 3x. Actually here two quantities are there. See left hand side part x square plus 2x plus 5. Right hand side part 3x is there. To relate these two things, I used the symbol equal. So what is this? This is an equation. Further, we can simplify this. Okay, between two real numbers or two algebraic equations, if we use the symbol equal, then it forms a equation. I hope you understand. Then what is inequality? You observe here, what is inequality? Inequality definition is like this. See, inequality definition is two real numbers or two algebraic expressions related by the symbols. You see, this symbol is, we call it as less than, moreover we call it as strictly less than. This is strictly less than. Okay, this symbol we call it as less than or equal to. See here, equal line type is there. The symbol we call it as less than or equal to. This symbol is greater than. This is greater than symbol. The symbol is greater than or equal to. Forms an inequality. Two real numbers or two algebraic expressions are related with these symbols forms an inequality. For example, 2x plus 3 is one algebraic quantity. 5 is another algebraic quantity. If we use an inequality symbol, we know that any one of these symbol, inequality symbol, I written greater than here. What is this? This is an inequality. This is one inequality. Okay. Now, I'll take one more. X square plus 5 is less than or equal to minus 2. Actually, what is this? Left hand side part, one algebraic expression is there. Right hand side part, one algebraic expression is there. These two are related with this symbol, right? One of these symbols, if we use, what is this? This is inequality. What is this? This is an inequality, right? This is one inequality. This is one inequality. So you learn what is equation, what is inequality, what are inequalities. Okay. See, solving equation, solving inequalities, so much difference is there. See, solving an equation, see, till now you've done so many equations and you find out its x values or y values, whatever it is, depends upon the equation. Solving an equation, you see here, this is one equation, 2x plus 1 equal to 3. If I solve this equation, what x values I'll get? See here, 2x equal to 3 minus 1 is 2. You can simplify this. X equal to 2 divided by 2. So x equal to 1. So I solved this equation. I got its solution as x equal to 1. Okay. This is solving an equation. How you identified it is an equation? Because between two algebraic expressions, there is a symbol equal, right? So this is the procedure of solving equation. How we solve inequalities? You see here, same here one algebraic expression is there, here one algebraic expression is there. Between these two, inequality symbol is there. You know what are inequality symbols? What are inequality symbols? Look here, the symbols are there. Na? These symbols are called inequality symbols. Less than or equal to, greater than or equal to, are called inequality symbols. Okay. Now, how to solve this? Actually, without knowing few rules, you cannot solve it. Just to explain the difference between equation and inequalities, I'll solve this. But without knowing rules of inequalities, you cannot do this. Just to explain the difference between solving equation and solving inequation, I am doing this. Right? After this, in next slide, we are going to learn what are those rules to solve an inequality. Okay. Here you see 2x plus 1 greater than 3. This is an inequality because of this symbol. Okay. Now 2x is greater than 3 minus 1. Okay. 2x is greater than 3 minus 1 is 2. Here I am dividing with 2. Actually, you cannot do like that. I am saying that just to explain the differences between these two. I am doing my own. You see, to subtract, there is a condition. To divide, there is a condition. All those things we are going to learn in the next slide. Okay, just wait. This can be written as x greater than 1. Okay, so x greater than 1. X greater than 1 means what? Here we suppose that x is a real number. We suppose that x is a real number. 2x plus 1 is greater than 3 and x is a real number. So when I solve this inequality, I got like this. When I solve this equation, I got like this. If I solve an equation, I got only one solution. One x equal to 1 is the solution of this equation. But here, for this inequality, how many solutions are there? You can see infinitely many solutions are there. Okay, you see, I'll try to explain this on the number line. X greater than 1. X greater than 1 means here strictly greater than is there. See here, strictly greater than is there. When strictly greater than is there, 1 is not included. Okay, 1 is not included. Greater than 1 means right hand side part of 1. All these numbers are greater than 1. 1.5 is greater than 1. 2.5 is greater than 1. All these, whatever number you take here, so anywhere you take here, all those numbers are greater than 1, right? Here, for this, so many solutions are there. How you write this in interval form? Just now you learned about intervals. How you write this in interval form? We'll write like this. X belongs to open interval because this is strictly greater than. 1 is not included. Open interval 1 to infinity. In this, you see so many numbers are there. Infinitely many numbers are there. This is solution of this inequality. For this inequality, number of solutions are infinite. 1.1, 1.2, 1.3, 2.1, 2.3, 2.01, 2.9999. All are solutions of this inequality. But for this equation, only one solution is there. X equal to 1 is the only one solution. Okay. So now we are going to learn how to solve an inequality. See, you know how to solve an equation. Till now you learn how to solve equations, right? Now, how to solve an inequality? To solve an inequality, we need to know mainly four rules. Mainly four rules are there. Rule number one, you see, what is rule number one? Rule number one, for an inequality, if we add or subtract same real number on both sides, then sign of inequality remains same. You consider one inequality. Okay, for that, we'll add, I'll take only add, this we'll discuss later. I'll add same real number on both sides, then sign of inequality remains same. You observe here 10 greater than 2 is there here, right? 10 is greater than 2. Is it true? Yes, this is true. 10 is clearly greater than 5. 10 is clearly greater than 5. Yes, this is true. Okay. Now, for this inequality, I'll add same real number on both sides. Then sign of inequality remains same or changes, we will see. You select one number, that number will add on both sides. For example, I'll take 2. Add 2 or else add 6. Add 6 to this inequality on both sides. 10 plus 6 is greater than 5 plus 6. Okay, 10 plus 6 is 16. 16 is greater than 5 plus 6 is 11. You observe 16 is greater than 11. It is true or not? Is 16 is greater than 11? Yes, 16 is greater than 11. See, I taken one true inequality. You need to take an inequality with here between two real numbers I am saying. For an inequality, if we add same real number, you observe here, if we add same real number on both sides, inequality sign remains same. That means here greater than is there. That greater than remains greater than only. For an inequality, if we add same real number on both sides, then sign of inequality remains same. You see, this works for subtraction also. Here, I taken this example. 3 is less than 10. Is it true? Yes, 3 is less than 10. For this inequality, you subtract same real number on both sides. Sign of inequality remains same or changes, you check. Here 3 is less than 10. I'll take one number. 3, 5. I'll subtract 5. 10 minus 5. For this inequality, I am subtracting 5. Right? 3 minus 5 is what? 3 minus 5 is minus 2. 10 minus 5 is what? 10 minus 5 is 5. What symbol is suitable here? Less than symbol is suitable or greater than symbol is suitable? Minus 2 is less than 5 is correct or minus 2 greater than 5 is correct? Clearly, this minus 2 is less than 5. That means what happened? This inequality sign changed or remains same? It remains same, right? So, it is important. You need to know this property. What is this property? For an inequality, if we add same real number on both sides, then sign of inequality remains same. You can say like this also. For an inequality, if we subtract same real number on both sides, then sign of inequality remains same. You see here, this is one inequality here. For this inequality, if I add or subtract same real number on both sides, sign of inequality remains same. This is the first rule. Whenever we solve inequalities, you need to consider this. If this is, see here, this is you see, this is a one unknown value is there in this. In this one unknown value is there, x. So if while solving this, solving this is nothing but finding x values. Solving is nothing but for what x values this inequality holds good, right? Okay, for what x values this inequality holds good. How to solve this inequality? See, I want x. For that, what I'll do, I'll subtract 5 on both sides. Here, x plus 5 is greater than 2. I'll subtract 5 on both sides. Yes, subtract 5 on both sides. What you will get? X plus 5 minus 5. So I'm subtracting 5 on both sides. What you know? For an inequality, if you subtract same real number on both sides, sign of inequality remains same, right? So this is greater than 2 minus 5. Okay, here plus 5 minus 5 will get cancelled. What you will get? X is greater than 2 minus 5 is minus 3. Actually, whenever we add, subtract, you can simplify this same like an equation procedure, but when we multiply with positive real number, negative real number, things will change. That we'll discuss in rule number 2. So what you got here, if x plus 5 is greater than 2, x is greater than minus 3. Okay, so this is solution of this inequality. If you want to write this in interval form, how you will write? We'll write like this: x belongs to open interval minus 3 to infinity. Okay, right. Now, what you learn? Rule number 1 you learn. What is rule number 1? For an inequality, if we add or subtract same real number on both sides, sign of inequality remains same. Okay. Second inequality, you observe, for an inequality, if we multiply or divide with same positive real number on both sides, then sign of inequality remains same. See, this is also sign of inequality remains same. Here what we are doing, if we multiply or divide with same positive real number. For an inequality, if we add or if we subtract, if we multiply or divide with same positive real number on both sides, sign of inequality remains same. I hope you are understanding. See, this is one inequality. For this inequality, you can add any real number. You can add any real number on both sides. Rule number 1 I am saying, you can add any real number on both sides, then sign of inequality remains same. For this inequality, if we subtract any real number on both sides, then also sign of inequality remains same. That is rule number 1. What is rule number 2? For an inequality, if we multiply with if I multiply with the same positive real number, same positive, here this is important, same positive real number, then sign of inequality remains same. If I multiply with negative real number, sign of inequality changes. That we'll discuss in next point. Okay, so this is 2 less than 5. You take one positive quantity, take one positive quantity, take 3, multiply with the same positive real number on both sides. 2 into 3 is less than 5 into 3. 2 into 3 is what? 6. 5 into 3 is what? 15. 6 is less than 15, right? 6 is less than 15. Is it true? Yes, this is true inequality. After multiplying with same positive real number on both sides, then sign of inequality remains same. See, this is one inequality. If I multiply or divide with the same positive real number, then sign of inequality remains same. For example, I'll divide with 2. Okay, 2 is a positive number. I divide with 2. 5 divided by 2, 3 divided by 2. What is 5 divided by 2? 5 divided by 2 means half of 5. Half of 5 is 2.5, right? 3 divided by 2 is half of 3. Half of 3 is 1.5. See here, 2.5 is greater than 1.5 or less than 1.5? 2.5 is clearly greater than 1.5. That means for an inequality, if I divide with a positive real number, inequality sign remains same. So what is suitable symbol here? Greater than, because 5 by 2 is 2.5. 3 by 2 is 1.5. 2.5 clearly greater than 1.5. So what you are understanding, there is an inequality. For that inequality, if I multiply with the same positive real number on both sides, or if I divide with the same positive real number, if I divide with the same positive real number on both sides, sign of inequality remains same. For example, here 2x less than or equal to 4 is there. I'll divide this on both sides with the 2. Not only 2, any positive real number. 2x divided by 2, 4 divided by 2. See, this is an inequality. Actually, this is an equation. In this unknown value is there. X is the variable. We need to find x. So as I divided with 2 on both sides, what is this rule says? There, if there is an inequality, if you multiply or divide with same positive real number on both sides, sign of inequality remains same. So what we'll write here? Less than or equal to we'll write, or greater than or equal to we'll write. As 2 is a positive real number, as we divided with positive real number, the sign of inequality remains same. That means 2, this is less than or equal to. So if I simplify this further, what I'll get? I'll get that x less than or equal to 4 by 2 is 2. So what is this? This is solution of this inequality, right? So how you will write this in interval form? Number line, you observe the number line. On the number line, if you mark the 2, left hand side part, whatever the numbers are there, they are all less than 2. Here less than or equal to given, that means 2 is included. You can observe that this highlighted part is there. That highlighted part is the solution, right? So how you write it as from minus infinity to 2. You can observe here less than or equal to is there. That means this 2 is included. When 2 is included, at that time we will write closed interval, right? We will write closed interval minus infinity to 2, right? I hope you are understanding. Now see rule number 3. In this inequalities, what is rule number 3? For an inequality, if we multiply or divide with same negative real number, this is important. If I divide with same negative real number on both sides, sign of inequality changes. Sign of inequality changes. Look here, sign of inequality changes. This is important. Till now, whatever rule 1, rule 2 are there, you see, remains same. Rule 1, you see, sign of inequality remains same when we add or subtract same real number on both sides. Rule number 2, see, when you multiply divide with same positive real number, sign of inequality remains same. Rule number 3 is what? When we multiply or divide with same negative real number, sign of inequality changes. First time you are seeing this, sign of inequality changes. You see here, minus 3 is less than 5. Is it true? Yes, clearly minus 3 is smaller than 5. Minus 3 is less than 5. What I'll do, I'll multiply with the same negative real number on both sides. You take one negative real number, multiply on both sides. Negative real number, I'll take minus 2. Minus 3 into minus 2. I'm multiplying. Okay. 5 into minus 2. Okay, what happened? This is the inequality. For this inequality, I am multiplying with same negative real number on both sides. As per this property, they are saying inequality sign changes. That means less than is there, no? Less than changes to greater than. Let's see what will happen. Minus 3 into minus 2 is what? Minus 3 into minus 2 is 6. Okay. 5 into minus 2. 5 into minus 2 is what? Minus 10. You tell the relation between the 6 and minus 10. Is 6 is greater than minus 10 or 6 is less than minus 10? All positive numbers are greater than negative numbers clearly. So what is this? 6 is greater than minus 10 is correct. I hope you are understanding. So what is the point here? For an inequality, if we multiply with same negative real number on both sides, sign of inequality changes. This is important. For an inequality, if we multiply with negative real number, sign of inequality changes. So here less than is there, as we are multiplying with minus 2, this inequality changes to less than. I hope you are understanding. Similarly, you see here 5 is greater than 3. Is 5 is greater than 3? Yes, this inequality is true. For this inequality, if I divide with same negative real number on both sides, if I divide with same negative real number on both sides, okay, 5 divided by minus 2, 3 divided by minus 2. What is 5 divided by minus 2? 5 divided by minus 2 is minus 2.5. 3 divided by minus 2 is what? 3 divided by minus 2 is minus 1.5. Which one is bigger, which one is smaller? I'll explain this on the number line. You observe this number line. Where is this minus 1.5? Somewhere here. This is minus 1.5. I'll mark this here. This number is minus 1.5. Where is minus 2.5? Minus 2.5 is here. See, minus 2.5. Please observe. This number is clearly smaller than this number. See, for you see this minus 1.5 is there. This side, whatever numbers are there, they are all less than this minus 1.5. Left hand side part. Minus 2.5 is left side of this number. So minus 2.5 clearly less than. So here this is clearly less than. But actual inequality sign is greater than. As we divided with the same negative real number on both sides, Sign of inequality changes. This greater than is changes to less than. So what happened here? What to write? As 5 is greater than 3 is a true inequality. As I am dividing with the same negative real number on both sides, sign of inequality changes. This greater than changes to less than. I hope you are understanding, right? So this third rule is very, very important. You just do little bit of practice. Okay, I'll give some examples also. You practice those inequalities, then you will get clear clarity about these rules. Okay, now you see, this is important. Do not cross multiply in inequalities. Do not cross multiply in inequalities. Many students will do this mistake, like suppose 2 by x equal to 3 is there. What is x means? What they'll do? They'll cross multiply. They'll say the answer is x equal to 2 by 3. But in inequalities, you cannot do like that. You cannot write 2 by 3 greater than x. Is wrong. This is wrong. You cannot declare like this, right? We cannot cross multiply. What we can do, if you want to solve this, we can multiply. See, I'll multiply with x into 2 divided by x, 3 into x. If I write like this, left hand side part, you observe x will get cancelled. Now the point is, as we are multiplying with some number, inequality sign changes or remain same. For that, you need to know x is positive or negative. If x is positive, inequality sign remains same. I hope you are understanding. Rule number 2. For an inequality, if I multiply with a positive real number, inequality sign remains same. In case if x is negative, when I multiply with x on both sides to the inequality, in that case, inequality sign changes. This greater than changes to less than. So here the problem is, we cannot solve this inequality until we don't know what is x. What is x means? X is positive or negative. You must know. Simply, if you solve this as 2 divided by 3 greater than x, 2 divided by 3 greater than x means x is less than 2 by 3. If you write like this, it is wrong. I hope you are understanding what I am trying to say. Here you see 2 by 3 greater than x means x is less than 2 by 3. I written reverse order. For example, 2 is less than 3 is there. 2 is less than 3. That means 2 is smaller than 3. When I write this in reverse order, like 3 is obviously greater than 2. I hope you are understanding. This can be understood easily. Suppose 5 is greater than 2. When I write the reverse order, this inequality changes. 2 is less than 5. Okay. So here I got like this. This can be written like this, x less than 2 by 3. If I do like this, what I did, I done actually cross multiplication. But unless if you don't know what is x, this is 100% wrong. You cannot cross multiply. This method is wrong. Do not cross multiply. Do not cross multiply in inequalities. You cannot cross multiply in inequalities. When you can cross multiply in inequalities, see, we can cross multiply when we know the sign of that variable, right? For example, you see here, we need to solve this inequality. Look here, we need to solve this inequality, 2 by x greater than 3. If you know that x is greater than 0, in the question only they mention that x is greater than 0. Greater than 0 means x is positive. Greater than 0, all numbers are positive. If you know all numbers are positive, you can solve this. How? I'll multiply. I am not cross multiplying. You try to understand. I'll multiply with x on both sides. Multiply with x on both sides. X into 2 by x greater than, here 3 into x. Now you see what is x? X is positive. X is positive. As x is positive, you know that from rule number 2, for an inequality, if we multiply with same positive real number on both sides, sign of inequality remains same. That means greater than remains greater than only. I hope you are understanding. Right now, what happened? This x will get cancelled. What you will get? 2 is greater than 3x. Right now, I'll divide this inequality with 3. As 3 is positive real number, for an inequality, if I multiply or divide with a positive real number, inequality sign remains same. Here now this 3 will get cancelled. What you got here? You got that 2 by 3 greater than x. Look here, 2 by 3 greater than x. 2 by 3 greater than x can be written as x less than 2 by 3, right? So what you got here? You got that x is less than 2 by 3. Now you may question, sir, we got the same solution, sir, if we do like this. If I do like this, I got same thing. If you do like this also, you got the same solution. I got this solution because I know x is positive. If x is negative, then this is not the solution. You see here, we'll solve that also. This is the inequality we need to solve, and we know that x is negative. We know that x is negative. Okay, I want to find x from this inequality. Okay, right. For that, what I'll do, I'll multiply with x on both sides. Here, what you know, x is negative. What you know here, x is negative. For an inequality, if for an inequality, if I multiply with negative real number, sign of inequality changes. Rule number 3. Here, greater than is there, now that changes to less than. Okay, that changes to less than. Now this x will get cancelled. What you got? 2 is less than 3x. Now what I'll do, I'll divide with 3 on both sides. I'll divide with 3 on both sides. As 3 is a positive real number, for an inequality, if I divide with same real number, inequality sign remains same, less than remains less than only. So I'll divide this inequality with 3. Now see what happens, this 3 will get cancelled. What you will get? 2 by 3, you see here, what you got here, 2 by 3 less than x. 2 by 3 less than x. It can be written as x greater than 2 by 3, right? So what you got here from this, you got that x is greater than 2 by 3. You observe the solution. You see, you observe these two solutions. When x is greater than 0, this is the solution of this inequality. If x is less than 0, see here, x greater than 2 by 3, here x less than 2 by 3. Solution difference is there. See, on the number line, somewhere if 2 by 3 is there, for this inequality, when we know x is greater than 0, x less than 2 by 3, x less than 2 by 3, this part is the solution, left hand side part. If this is the inequation, if you know x is less than 3, x greater than 2 by 3, this is the solution of this inequality. I hope you are understanding the difference. So in cross multiplying, don't cross multiply without knowing its sign, right? If you know the sign of that particular variable for an inequality, if I'm multiplying with negative real number, if you are multiplying with positive real number, it's okay. Without knowing that whatever number you are multiplying, suppose x is greater than y is there, I'll multiply with some z. I'll multiply with some z. Xz is greater than y into z. This is wrong because you need to know z is positive or negative. Based on that, this inequality sign changes. Union of intervals and intersection of intervals. We use this union of intervals and intersection of intervals very frequently in wavy curve method, right? Union of sets, actually you will learn this in sets chapter, but as it is needed, that's why I'm discussing this. Union of intervals and intersection of intervals. For example, something given like this, x belongs to this interval, the symbol is known as union, intersection this. How you read this? Closed interval minus 2 to 1, union closed interval 2 comma 4. What it mean? How we represent this on the number line? First, I'll draw the number line, and whatever the numbers are there here, I'll mark as per number line order. See, what it mean, x belongs to union of these intervals means x can be in this interval. That means x can be this value or x can be this value. Union means the value which may be in this set or in this set, or it can be in both sets also. That also we'll discuss an example, right? Suppose if they ask like this, how we'll mark this union? You see here closed interval is there. Na? When closed interval is there, then minus 2 is included. When it is included, we'll write a dark circle. Okay, minus 2 is included to 1, up to 1. Look at this part. For one open interval is there, na? So 1 is not included. This part union closed interval 2 to 4. See, closed interval 2 means 2 is included, 4 is also included, and this part. Whenever they give x is in this interval, or whenever you something like this, you got answer like this. Suppose when you use wavy curve method, something you got like this. Then how you write this? You write that x belongs to, here this point is included, na? Closed interval minus 2 to open interval 1 union closed interval 2 comma 4. You must know that. Usually you will get this part. From this we'll find the interval. Suppose while solving the problem, you got solution like this. that means this part is there. This is included in the solution, and this is also included in the solution. In that case, how you write this interval? We write this interval like this. X belongs to, you see here, at -1 there is an open circle, that means -1 is not included. So x belongs to open interval -1 to, you observe here 4 is included. This full part is there, -1 to closed 4, and this is also part of the solution. How you write this? By specifying union, right? Specify the union. You see here in this 6 is not included, right? Open interval 6, 7 is also not included. So open interval 6 comma 7. Whenever you see something like this, union symbol, that means that x values are in this interval or in this interval, or it can be both if possible, right? Okay. Now you see this symbol is known as intersection. Intersection of two intervals. This is interesting and important also. First, I'll mark this on the number line. You observe whatever the numbers are there, you mark them as per number line order. First, I'll mark this interval, closed interval -1 to 3. As closed interval is there, -1 is included, 3 is also included. This is the solution. Now, I'll mark this second interval. What is the second interval? Closed to open 4. The interval closed to open 4. You observe here, I'll mark here the interval closed to open 4. See, this is the solution of first interval. This is the solution of second interval. Intersection means the elements which are common in both. Intersection indicates that the elements which are common in both. You observe both the lines. In both the lines, which part is common? You observe this is the common part, right? So what is intersection of these two intervals? Intersection of these two intervals is, you observe the common part. 2 is there in both the solutions. Yes, 2 is there. So closed to 2, you observe here up to here 3 is there in this interval, 3 is there in this interval also. This intersection is nothing but closed interval 2 comma 3, right? See, intersection is nothing but common part, elements which are common in both. If they ask what is intersection of these two intervals, we'll observe the common part. If there is no common part, we will say intersection of those two intervals is empty, nothing is there, right? In these two intervals, there is some part common. That is the intersection of intervals. When it comes to union, it won't be like this. Union means x value can be here, x value can be here, or x value can be in both. Okay. I hope you understand about union of intervals and intersection of intervals. You will learn this more clearly in sets chapter. You do not worry in case if you didn't understand more clearly. The inequalities for real x. Whatever we will solve x values, they are the real x values. Okay. Whatever x values we will solve, they are all real x values. Okay. Fifth question. What they are asking in this question? They are asking to solve this inequality for real x. You observe, I want to solve for x now. I want x values. To get x values, what I'll do? All x terms I'll write here. General method I said, general method. 4x plus 3 is less than 5x plus 7. Actually, I am not going to do in this method. This is the first problem. Now you need to know actually what is the exact method. I want all x terms only. So for that, what I'll do? I'll subtract 3 on both sides. Just to get x terms only on the left hand side part. For an inequality, look here, 4x plus 3, subtract 3 on both sides, 5x plus 7 minus 3. This is the inequality. For an inequality, if we subtract with same real number on both sides, sign of inequality remains same. That is rule number 1. This less than remains less than only. Now you can check here, plus 3 minus 3 will get cancelled. What you will get? 4x less than 5x. Look here, 7 minus 3. 7 minus 3 is 4. Okay, plus 4. Now what I'll do? Actually, I want all. I'm trying to solve x values now. I'm solving for x values here, right? So here, I need to write all x terms at one side. What is x here? X is a real value. So what I'll do, I'll subtract 5x to this on both sides. Listen carefully. Actually, this is not the method. I'm going to erase all these things. 5x plus 4 minus 5x. X is a real number. In the question only they said x is a real number. 5x is also real number. I am subtracting 5x. This is the inequality. For this inequality, I subtract 5x on both sides. Rule number 1 is what? For an inequality, if we subtract same real number on both sides, the sign of inequality remains same. That means this less than remains less than only. This is what rule number 1 is saying, right? Now you look right hand side part, this plus 5x minus 5x will get cancelled. Now left hand side part you observe 4x minus 5x, that is minus x less than 4. I got like this. Now this is the inequality now. I'm trying for x now. I'm looking for x value now. Here minus x is there in the left hand side part. What I'll do, this inequality I'll multiply with minus on both sides. This inequality I'll multiply with minus 1 on both sides. If I multiply with minus 1 is negative real number now. Minus 1 is negative real number. For an inequality, if we multiply with negative real number, inequality sign changes. That is rule number 3. When you multiply with minus, what you will get? This is x, inequality sign changes. Less than changes to greater than. This is minus 4. Okay, so you got solution like this, but no need of writing all these steps. No need of writing all these steps. This is the actual method. If you want to use rule 1, rule 2, rule 3, this is the actual method. Listen, I'll just keep this aside. How you can do this problem very easily. Actual method is this only, but not necessary. In exam also, what method I am going to explain here, that you can follow. Right, this is the inequality. I need to solve this inequality. Very simple. You write all x terms at one side, all remaining all terms other side. In this inequality, you write all x terms at one side, remaining all terms other side. Let me check here. Here, my plus 5x is there now. You take plus 5x to the left hand side part. Then what you will get? You will get minus 5x, right? 4x minus 5x. What I am doing? I am writing all x terms at one side, 4x minus 5x. Here less than symbol is there, now you keep it as it is. 3 is there, now take it to the right hand side part. What you will get? 7 minus 3. You got this step. You look here, without doing this step, directly you are getting, directly you got this step actually. See, without doing all these things, directly you got this. Please try to understand what happened here actually. I taken 5x to this side means I subtracted 5x on both sides. That you need to keep in your mind. When you subtract a particular real number on both sides for an inequality, inequality sign remains same, less than remains less than only. I taken 3 to this side means for this inequality, I subtracted 3 on both sides. It can be understood easily. No need to do like this for every problem. This is the inequality. You write all x terms at one side, remaining all terms other side. Okay, you look here, 4x minus 5x, that is minus x, less than 7 minus 3 is 4, right? Now what I am trying for, I am solving this. That means I am looking for x values. To get x values in the left hand side part, I want x. To get x, I will multiply this inequality with minus 1. Multiply this inequality with minus 1. When we multiply this inequality with minus 1 is negative real number. When for an inequality, if we multiply with negative real number, inequality sign changes. This less than changes to greater than. Minus of minus x is x. X greater than. Minus 1 into 4 is minus 4. You see how simple you got this. No need of doing this procedure. Right? X greater than minus 4. Right? Now, what the question? What real values of x satisfies this inequality? You take any real x value which is greater than minus 4 that satisfies this inequality. Here, I'll try to explain with the help of where is minus 4? Mark minus 4 here, minus 5 will be there. Here minus 4 is there. Here minus 4 is there. Okay. You remember, you mark minus 4 on the number line. Right hand side part of minus 4, all numbers are greater than minus 4. Right hand side part of minus 4, whatever numbers are there, they are all greater than minus 4. Left hand side part of minus 4, what numbers are there, they are all less than minus 4. Here I want x values which are greater than minus 4 now. What are the x values which are greater than minus 4? You observe right hand side part. You can see this marked one. Can you see? Yes. This marked one. What is this? This is the solution. So if you want to write this in interval form, you need to write like this. Here, this is greater than. In the symbols, two types are there. This is greater than or equal to. When greater than or equal to given, we will write closed bracket. When strictly greater than is given, we will write open bracket. Strictly greater than or strictly less than. Okay. Here this is strictly greater than. So our answer will come in open interval form. Greater than minus 4 means you need to write this solution. From where to where? Minus 4 to infinity. Okay. Minus 4 to infinity. I hope you are all understanding. So these in this interval, whatever the real values are there, all those real values satisfies this inequality. This is the solution of this inequality. For example, in this interval 0 is there. In this interval 0 is there. Yes, 0 is there. So 0 is the solution of this inequality. It means when I substitute 0 in this, it satisfies. In place of x, you write 0. 4 into 0, 0. 0 plus 3, that is 3, less than 5 into 0, that is 0. 0 plus 7 is 7. Is 3 is less than 7? Yes, 3 is less than 7. So whatever real x values you take in this interval, they are the solution of this inequality. I hope you are all understanding, right? So I don't want to do this sixth question. This is similar. This question is similar to this fifth question. I want you to try this question. So sixth question, you please try. I'll mark what is the answer for this. Answer is like this. X belongs to open interval minus infinity to minus 3 you will get for this problem. This is the answer for this problem, second problem, right? I want you pause this video, try this your own and make sure you will get this answer or not, right? Good. So 5, 6, 2 problems are over. Now we will move to seventh problem. Seventh problem, eighth problem. You observe seventh problem, eighth problem, almost a similar type. Okay, I do one problem, you do other problem. Eighth problem you need to do. I'll write the answer after completion of the seventh problem. Okay. Seventh problem. How to solve? What the point here? We need to solve this inequality. We need to find real x values which satisfies this inequality. Very simple. First, this left hand side part you simplify, right? Multiply with 3. What? I'll write the question. 3 into x minus 1 is less than or equal to 2 into x minus 3. This is the given question. Now what I'll do? I'll solve this left hand side part. Solve this left hand side part. Multiply 3x minus 3 less than or equal to. Now right hand side part you multiply 2 into x minus 3. What is that? That is 2x minus 6. Now further how to do this problem? Actually, to get x values, first we will add 3 on both sides. Afterwards some number you will get. That number we will subtract on both sides. I will try to get x values. That what I explained in the beginning. No need of doing all those things. In exam also no need of doing all those things. Very simple. Here you write all x terms at one side. You write all constants other side. Okay. Here 3x minus 2x is less than or equal to. Here minus 6 is there. You take minus 3 to the right hand side. That means that is plus 3. Actually in this step, after this step what happened? I taken 2x to this side means for this inequality, I subtracted 2x on both sides. When I subtract 2x on both sides, right hand side part 2x will get cancelled. Afterwards, I taken minus 3 to this side means what? I added 3 to this on both sides. For an inequality, if we add or subtract a real number on both sides, then inequality sign remains same. That's why less than remains less than only. I hope you are all understanding. You make sure that you are not multiplying with a negative real number. When you multiply with a negative real number, then only sign of inequality changes. Or else if you multiply or divide with a positive real number, inequality sign remains same. If you add or subtract with same real number on both sides, then also inequality sign remains same. First 3 rules in first class we learned now. Okay, 3x minus 2x, that is x. X less than or equal to minus 6 plus 3. Minus 6 plus 3 is minus 3. So x less than or equal to minus 3. You take any real x value which is less than or equal to minus 3 that satisfies this inequality. I'll take the number line to just identify the solution. Here minus 3 is there. Na? You mark it. Where is minus 3 on the number line? You can look here. Here is the minus 3. Greater than or equal to is there. Left hand side part of minus 3. Left hand side part of minus 3. Whatever numbers are there, they are all less than minus 3. Right hand side part of minus 3, whatever numbers are there, they are all greater than minus 3. Keep this in your mind. Here I want less than or equal to minus 3 means left hand side part numbers I want. Left hand side part means here minus infinity will be there. So x belongs to, what to write here? X belongs to, for infinity always open bracket because infinity is not defined. Infinity is not defined. What is the answer? X less than or equal to minus 3 means? Actually you can stop here, but I am writing this in interval form. Minus infinity to 3, minus infinity to 3. For this 3 closed bracket or open bracket. Here less than or equal to is there. Less than or equal to is there. That means when less than or equal to is there, we will write closed bracket. When strictly less than is there, at the time we will write open bracket. Okay, here less than or equal to is there. That's why this is closed bracket. So for 7th problem, answer is minus infinity to closed 3. You take any real x value in this interval, substitute in this inequality, definitely it satisfies. For example, in this 1 is there. In place of x, you put 1 in this. In place of x, you put 1. Left hand side part will become 0, less than or equal to 2 into, in place of x, you put 1, 1 minus 3. 1 minus 3 is what? Minus 2. What happened here? Minus 3, minus 3, minus 3, minus 3. Look here, look here. Here, less than or equal to minus 3 is there. Less than or equal to minus 3. Which question I am doing? 7th question. 7th question. X less than or equal to minus 3. Correct. Minus 3. X less than or equal to minus 3. Right. You can see here what happened in this. In this 1 is not there. That's why that is not satisfying this inequality. It's good that we are checking. Right. In this, you take any real x value in this interval, substitute in this, it definitely satisfies. Here x less than or equal to minus 3 we got now. Right. In this, what number is there? Minus 4 is there. You can observe here all numbers less than or equal to minus 3. In this, minus 4 is there. Substitute minus 4 in this, definitely satisfies. 3 into minus 4 minus 1, that is minus 5, less than or equal to 2 into, in place of x, what I am writing? In place of x I am writing minus 4 na? Minus 4 minus 3, that is minus 7. Okay. So minus 15 is less than or equal to minus 17. Right. So I hope you are all understanding. In this interval, you take any real x value, substitute in this, definitely it satisfies. Similarly, I want you to try this 8th problem your own. For this 8th problem, answer is like this. Open interval minus infinity to closed 4. This is closed 4 because in this question greater than or equal to is there. Na? This is the answer you will get when you solve this 8th question. Okay. Now we'll move to next set of questions. 9th question, 10th question. I'll do 9th question. You try 10th question your own. Both are same type na? Okay. So how to solve this 9th question? First thing, what they given? X plus x by 2 plus x by 3 is less than 11. Generally what we'll do, we'll try to write all x terms at one side, remaining all other side. Right? So here already all x terms are at one side only. You just simplify this. Okay, just simplify. What is the LCM you will get? 6 is the LCM. Okay, what you will get in the numerator? 6x. Here by 1 will be there. X divided by 1 will be there. 6x plus, you all know these things how to write. 2 in 6 3 times 3x. 3 in 6 2 times 2x less than or equal to 11. Strictly less than. In the question strictly less than given. Okay. You observe 6 plus 3 9. 9 plus 2 11. 11x divided by 6 less than 11. Okay. Now you multiply both sides with the 6. You multiply. What I want? I want x values. I do one thing. I'll multiply with the 6 by 11 on both sides. Listen. What I want x values. That means in the left hand side part, I want x only. To get x only in the left hand side part, for this inequality, I'll multiply with 6 by 11. Look here. If I multiply with 6 by 11, 6, 11 will get cancelled, so that I'll get x only. I hope you are understanding. This is the inequality now. For this inequality, I'll multiply with 6 by 11 on both sides. 6 by 11 is positive or not? Yes, 6 by 11 is clearly positive. For an inequality, if we multiply with positive real number, inequality sign changes or remains same? Rule number 2. For an inequality, if I multiply with a positive real number, inequality sign remains same. So multiply with 6 by 11 on both sides. 6 by 11 into 11x by 6 less than 11 into 6 by 11. This is the inequality now. For this inequality, I multiplied with 6 by 11 on both sides. As 6 by 11 is positive, when we multiply with a positive real number, inequality sign remains same. Less than remains less than only. Now look here, this 6 will get cancelled. 11 also will get cancelled. This 11 also will get cancelled. What you will get? You will get that x is less than 6. In the question they given strictly less than. Here strictly less than is there. X is less than 6 I got. So answer. If you want to write the answer, how you will write? Less than 6. On the number line you mark 6. Left hand side part of 6, all numbers are less than 6. Right hand side part of 6, all numbers are greater than 6. No need of every time writing number line. Here I can write directly answer. X belongs to open interval minus infinity to 6. I hope
you are all understanding. If you are understanding these problems, please drop a like for these videos. Okay. Now I want you to try this 10th problem your own. See, mathematics you can enjoy not by listening. When listen first to learn. Afterwards, you take some problems and you try your own. When you try the problems your own, then only you can enjoy this mathematics. Mathematics is such a subject. If you are getting answers for every problem, complete night you can study without boring. But for the first problem only, in case if you felt bored, then we won't get interest to study mathematics further, right? So what I am trying to say, you can first learn this 9th problem. You learned this type of problems how to do. Then to get perfection, you must try one problem of your own. Okay, 10th question answer is what they given. 10th question answer is minus infinity to minus 6. This is the answer. X belongs to, you take any interval, any real value in this interval, that definitely satisfies this inequality. Okay, right. Now we'll move to next question. Right. 11th question, 12th question. Okay. 11th question, if you observe, first what I'll do in this 11th question, what I need to find, I need to solve this inequality. What real values of x satisfies this inequality? I'll simplify this left hand side part and then I'll simplify with this right hand side part. Let me start. Right, solution. 3 times of x minus 2 divided by 5 less than or equal to 5 times of 2 minus x divided by 3. First, simplify this left hand side part. Simplification means numerator multiply with 3. 3 into x minus 2. What is that 3 into x minus 2? That is 3x minus 6 divided by 5 less than or equal to. Here multiply with 5. 5 into 2. 10 minus 5x divided by 3. Actually, in inequalities, we cannot cross multiply. But when you are clear with the properties, you can cross multiply. Here you see this 3, 5 we can cross multiply because these two real numbers are positive numbers. These two are positive real numbers. When both the numbers are positive real numbers, we can cross multiply. We can cross multiply because for an inequality, if we multiply with positive real number, inequality sign remains the same. I hope you are understanding. Okay, we can cross multiply here. Actual point is, first I need to multiply with 5 on both sides. Next, I need to multiply with 3 on both sides. Like that we need to do. Not necessary, you just cross multiply. But make sure that there is these two are positive real numbers. Okay, positive real numbers. Now you can cross multiply. What you will get? 3 into 3x, that is 9x minus 6 3s are 18 less than or equal to 50 minus 25x. Okay, now somehow I got little simplest form. I need to solve this. To solve this, what I'll do? I'll write all x terms at one side, remaining all terms other side. Here minus 25x is there. You take it to the left hand side part. Ajay Dharmpuri, good morning sir. Good morning Ajay. You take minus 25x to the left hand side part. What you will get? 9x plus 25x. I'll write here 9x plus 25x less than or equal to, you take minus 18 to the right hand side part, then what it will become? 50 plus 18, right? 50 plus 18 is what? That is 68. So here this is a 34, right? 34x, 9x plus 25x is 34x is less than or equal to 68. 68. Okay. Now what I am trying for? I am solving for x values. I am looking for what real x value satisfies this condition. Now you observe, I got this one. I want x. In left hand side part, I want only x. So to get only x here, this is the inequality. Now for this inequality, you divide with 34 on both sides. You divide with 34 on both sides. 34 is positive real number. For an inequality, if you divide with positive real number, inequality sign remains same or changes. For an inequality, if you multiply or divide with a positive real number, inequality sign remains same. That means here less than or equal to is there. Now this less than or equal to remains less than or equal to only. Here this 34 will get cancelled. 34 in the 68 2 times. Correct? Yes, 2 times. So what you will get? X less than or equal to 2. X less than or equal to 2. You take any real x value which is less than or equal to 2, that definitely satisfies this inequality. So for example, you just mark 2 on the number line. Left hand side part of 2, all numbers are less than 2. Right hand side part of 2, all numbers are greater than 2. I hope you are understanding. So if you want to write this in interval form, how to write? X belongs to minus infinity to, for infinity, always open bracket. Whenever infinity will be there, always open bracket. Good. What are you using to write the screen? I am also trying YouTube channel. At the end of the class, I will discuss. Total 16 problems are there. After completion of 16 problems, I will discuss, Ajay. Right? If you want, you can stay. Right? Now it may create some disturbance in the class. Okay, minus infinity, I will explain. I will tell you what software I am using. It's not big secret. Less than or equal to is there. Equality is there. So I need to keep closed bracket. Minus infinity to 2. Okay. Good. Chirag Kumar, same. Very good, Chirag. I hope you are following these things. Good. So these, you take any real x value in this interval, that is going to satisfy this inequality. Okay. So I want you to try this problem. Very simple. First, you simplify left hand side part. You multiply with 1 by 2. Then what this will become? This will become 3x divided by 10 plus 4 by 2 is 2 greater than or equal to 1 by 3 into x is x by 3 minus 6 by 3 is 2. You will get like this. Afterwards, you write all x terms at one side, remaining all other side. Okay. And then you will get x values. For this problem, this is 12th problem. Now answer you must get. This is homework. I want you to do this problem your own. For this answer is minus infinity to open interval minus infinity to closed interval 120. This is the answer. Okay. Right. Now this 13th problem, 14th problem, both are similar type. You can observe 13th, 14th, both are similar type. Any 13th problem I'll do. I want you to do the 14th problem. Okay. 13th problem, what they given? 2 into 2x plus 3 minus 10 is less than 6 times of x minus 2. What we want? We want to find x values which satisfies the inequality. What real values of x satisfies this inequality? First, I'll simplify this left hand side part, simplify, and then simplify right hand side part also. Simplify, what you will get? 4x, 2 into 2x is 4x plus 2 into 3 is 6 minus 10 is less than what you will get? 6x minus 12. Okay, now you can observe here little bit simplification also possible. 4x, this is 6 minus 10 is minus 4 less than 6x minus 12. Now what I'll do? I'll write all x terms at one side, remaining all other side. Okay. So 4x minus 6x less than minus 12 plus 4. 4x minus 6x is what? That is minus 2x less than minus 12 plus 4. Minus 12 plus 4 is minus 8. Okay. Good. Now what I am trying for? I am trying for x values. Here left hand side part minus 2x is there. But I want only x. How I can get only x? For this inequality, I'll divide with minus 2 on both sides. For an inequality, if I divide with a negative real number, what happened? Rule number 3, inequality sign changes. Less than changes to greater than. Okay. So minus 2x divided by minus 2 minus 8 divided by minus 2. This is the inequality. Now I divided with minus 2 on both sides. Then inequality sign changes. This less than is there. Now less than changes to greater than. Okay, this minus 2 will get cancelled. This minus also will get cancelled. What you will get? You will get that x is greater than 4. That means right hand side part of number 4. All are greater than 4. Left hand side part of number 4 on the number line. All are less than 4. Here I want x values which are greater than 4. So what is the solution I'll write? I'll write x belongs to open interval 4 to infinity. I hope you are all understanding. And in same way, you please simplify this one. You just simplify this one like this is a minus 3x 37 minus 5, that is 32 less than greater than or equal to 9x minus multiply with 8x plus 24. And just you write all x terms one side like that you do, you will get the answer. I want you to try this 14th question your own. Okay. For 14th question, answer is open interval minus infinity to closed to. Okay. I hope you are all understanding. If you like these videos, please drop a like. Okay. Right. Next, we completed 14 problems. Very good. Good. Now you see this 15th problem. I said in this class we are going to do up to question number 16. Only these 2 questions are pending. I'll do both the questions. 15th question, 16th question, both I'll explain. Okay. 15th question solution. Okay. What they given? X by 4 less than 5x minus 2 divided by 3 minus 7x minus 3 divided by 5. So much of sweating. Okay. Alright. So here x by 4. How to solve this inequality? We need to find real x values which satisfies this inequality. First, what I'll do, this right hand side part, what is there? I'll simplify this. Right? This is normal simplification only. Okay, those who complete SLC, they can do it very easily. X by 4 less than, what is LCM? 3, 5 LCM, 15, right? Now what you will get? 3 in this 15, 5 times. So what you will get? 5 into 5x minus 2. 5 into 5 into 5x minus 2. Okay, minus 3 into 7x minus 3. I'm just trying to simplify this right hand side part. X by 4 is less than, this is 25x minus 10 minus 21x plus 9 divided by 15. Okay, x by 4 is less than, you look here, 25x minus 21x, that is what? That is 4x. 4x minus 10 plus 9, that is minus 1 divided by 15. Okay, now actually what I am trying for? I am trying for x values. You can observe here in linear inequalities we cannot cross multiply actually, but in the denominator both the numbers are positive real numbers. We can do multiply, cross multiply here, as these two are positive real numbers. You can cross multiply. What you will get? 15x is less than 16x minus 4. Okay, what you are looking for? You are looking for x. That means you want all x values at one side. So you write all x values at one side. What you will get? 15x minus 16x is less than minus 4. Okay, 15x minus 16x, that is minus x, is less than minus 4. Okay, what I am looking for? I am looking for x values. That means I want x in the left hand side part. To get x in the left hand side part, you multiply this inequality both sides with minus 1. Because I am looking for x values now. Minus 1 is the negative real number. For an inequality, if we multiply with negative real number, sign of inequality changes. Right? Multiply with minus 1 into x, that is plus x. As we are multiplying with negative real number, inequality sign changes. That means this less than is there, now less than changes to greater than. That is what we learn in rule number 3. Right? Greater than, minus 1 into 4 is 4. So x greater than 4. You take any real x value which is greater than 4 that satisfies this inequality. So here, what is the answer for this? X belongs to x greater than 4 means on the number line right hand side part of 4 all numbers are greater than 4. Okay, so 4 to infinity, you take any real x value in this interval, that satisfies this inequality. Right? I hope you are all understanding. Good. Now question number 16. Okay, right. This is the last question in today's class. Question number 16. Okay, right. I need to solve this inequality. I need to find real x values which satisfies this inequality. Okay. First thing, I'll write the question. What they given? 2x minus 1 divided by 3 is greater than or equal to 3x minus 2 divided by 4 minus 2 minus x divided by 5. Just written given inequality. To solve this inequality, first I'll simplify this right hand side part. Okay, right, good. So 2x minus 1 divided by 3 is greater than or equal to, how to simplify? LCM, right? 4 5s are, right? 4 5s are 20. Okay, and now this 4 in this 25 times, right? What you will get? 5 into 3x minus 2, okay, minus 5 in this 24 times. Okay, so 4 into Rajiv Kumar, good morning, minus 4 into 2 minus x. Okay, right. So here again further I'll try to simplify this part. Okay, 2x minus 1 divided by 3 is greater than or equal to, you just simplify this part. What you will get? 15x minus 10 minus 8 plus 4x divided by 20. You can observe in linear inequalities, generally we cannot cross multiply, but in the denominator, if both the numbers are positive, then you can cross multiply. Okay, just cross multiply here. What you will get? 20, that is 40x minus 20. What happened? 20 into 2x minus 1, that is 40x minus 20. Okay, and here simplification is there. Now little bit I will simplify. Listen, 2x minus 1 divided by 3 is greater than or equal to, look here, 15x plus 4x, that is 19x. 19x minus 18 divided by 20. Okay, yes Shiva, good morning. Good morning. Right, now here this is positive real number, this is positive real number. When these two are positive real numbers, you can cross multiply. Okay, cross multiply, what you will get? 20 into 2x minus 1 is greater than or equal to 3 into 19x minus 18. Now you simplify this left hand side part, what you will get? 40x minus 20 is greater than or equal to 3 into 19, that is 57x minus 3 into 18, that is 54. Okay, now you observe here I got somehow simplest form now. Now to solve this further, Sudeep Gurai, good morning to all. We are at the end of today's class. We are doing 16th problem. Right, now to simplify this further, what I'll do, I'll write all x terms at one side. Right, all x terms at one side, that means 40x minus 57x greater than or equal to minus 54 plus 20. Okay, 40x minus 57x, this is minus 17x. Minus 17x is greater than or equal to minus 54 plus 20, that is minus 30. Minus 34. Minus 34. Okay, now what I want actually? I want x values now. I want x values. To get x values, you divide both sides with minus 17. To get x values, you divide with minus 17 on both sides. Minus 17 is the negative real number na? For an inequality. If we divide with a negative real number, inequality sign changes. This greater than or equal to changes to less than or equal to. So here minus 17x divided by minus 17. Greater than or equal to changes to less than or equal to. Why? Because for this inequality, I am dividing with negative real number. For an inequality, if I divide with a negative real number, inequality sign changes. Now look here, this minus 17 will get cancelled, and this minus 17 in this 34 2 times, right? What you will get here? You will get that x is less than or equal to 2. So how to write this in interval form? You know that on the number line, left hand side part of 2, all numbers are less than 2. So x belongs to open interval minus infinity 2. Here less than or equal to is there na? When less than or equal to is there, at that time 2 is included. For infinity, always open brackets. So this is solution for this inequality. Whatever real x value you take which are less than or equal to 2, that real value satisfies this inequality.
Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is second class of linear inequalities. In first class of linear inequalities, we learn about intervals. What is meant by closed interval a comma b? What is meant by open interval a comma b? What is the meaning of the interval closed a open b? And the main rules of linear inequalities. This is second class. In this class, we are going to learn wavy curve method. In this wavy curve method, 2 to 3 types are there. This is type 1. Okay. How to identify it is type 1. You observe this given inequalities. You see, this is inequality. Why? Because inequality sign greater than is there. This is inequality. What is this type 1 means? First point, the inequality, this is the inequality. Now it must contains linear factors. Look here, x minus a, x minus b. Plus is also okay. Suppose if plus is there here, x plus a into x minus b greater than 0, that is also okay. And x coefficient must be 1. Look here, in case x coefficient is not 1, we'll make it 1. That also will come one by one. Problems will come one after another, right? If the problem is like this, right, we need to solve this inequality. That means what are the x values satisfying this inequality? How to solve this? By wavy curve method, that we are going to learn.
if the inequality is like this, see here greater than is there, not only greater than or equal to is also okay. We'll discuss all those things. Here you see less than 0 is there, not only less than or equal to also okay. This can be extended. For example, here product of three functions is there, x minus a into x minus b into x minus c. If they ask solve x values which satisfies this inequality, then we can use wavy curve method. Here less than or equal to is there, strictly less than is there, then also procedure is same. Okay, so first type is what? If given linear inequalities of this type, then how we solve with the help of wavy curve method. Right, we'll move to problems. You observe this question. See what they are asking, solve. You need to solve this inequality. You observe what is this inequality, x plus 3 into x minus 7 greater than 0. Solving inequality is nothing but finding the x values which satisfies this inequality. Finding the x values which satisfies this inequality. Okay, so first we will solve this. First point, what you identified here, linear factors are there. Okay, and x coefficient is 1 or not. Yes, this is a linear factor whose x coefficient is 1. Here 1 is there. This is also linear factor whose x coefficient is 1. Okay, now in step 1 what we will do, you see here, right here, what is the given inequality, x plus 3 into x minus 7 greater than 0. We are trying to solve this inequality. In step 1 what we will do, we will equate this to 0. X plus 3 equal to 0. Then what is x? X is minus 2. Okay, so equate x plus 3 equal to 0. From that you will get x equal to minus 3. Okay, now second one is then x minus 7 equal to 0. Equate that to 0. X minus 7 equal to 0. You will get x equal to 7. Right, so I equated these linear factors to 0. I got x values like this, x equal to minus 3, x equal to 7. Now you mark this minus 3 and 7 on the number line. You mark this minus 3 and 7 on the number line as per number line order. You just take a number line like this, minus 3 it will be like this, and somewhere 7 you will get here. You mark this minus 3, 7 on the number line. Now wavy curve method says that in the rightmost corner, you see rightmost corner, in this part rightmost corner you write plus, and then you write the alternate symbols, minus, plus. You write like this. This is wavy curve method says. Now you see here what they are asking, this inequality holds good for what x values. Here greater than 0 is there. Greater than 0 means all numbers are positive. See on a number line 0 is there here. Greater than 0 means whatever numbers you will take greater than 0, they are all positive. Yes, so here wherever the positive sign is there, you observe this part, this is the positive sign is there. In this part you take any number. That means suppose here 8 is there. If you take 8 100% satisfies this inequality. If you want you can check. See 8 plus 3. Here I am taking 8. I am saying that 8 satisfies this inequality. 8 plus 3, positive or negative? That much only we need. 8 plus 3 is positive. Okay. Now 8 minus 7. 8 minus 7 is positive or negative? Positive. Right? Positive into positive is what? Positive. I hope you are understanding. When I substitute x equal to 8 in this, what number you will get? That is 100% greater than 0. Not only that, you take any number here in this part. What numbers are there here? Minus 4, minus 5, like that. You take any number in this area. If you substitute that number in this inequality, it must and should satisfy. For example, here minus 4 is there. Substitute minus 4 plus 3. Substitute here minus 4 plus 3. Minus 4 plus 3 is minus 1, that is negative, into. Substitute here in place of x you write minus 4 minus 7, that is negative. Negative into negative is what? Positive. I hope you are understanding what I am trying to say. So whatever x values you take in this zone as well as in this zone, this inequality will be greater than 0. Right? So what is the solution of this inequality? I can write like this, x belongs to, see here I'll just highlight this area, see this part, because why this part only? Because here greater than 0 is there. Greater than 0 means we need to look for positive sign. Okay, here right, write like this. First I'll write this zone, right? What is this? Minus infinity to, for infinity always open bracket, right? Here minus infinity to minus 3 na, minus 3. Here it is closed bracket or open bracket. This is the question mark now. Here what we need to write? Closed bracket or open bracket. Here strictly greater than is there na. When strictly greater than is there, you will write open bracket. Suppose same question they given like this, greater than or equal to. In that case we will write closed bracket. In this question strictly greater than is there na, so you write open interval minus 3. Here greater than 0 means positive sign na. Positive sign means what this, see what you will get here, this is union. Union means plus, right? In set chapter you will learn this. Okay, 7 to infinity, right? So whatever x value you take in this interval, if we substitute in this inequality, it satisfies. So this is the solution of this inequality. Okay, suppose same question they given like this. They given like this, x plus 3 into x minus 7 less than 0. Same question. What is the difference here? Greater than is there, here less than is there. In that case also what we will do, first you observe this, these are linear factors, x minus a into x minus b form, right? X minus a into x minus b form, yes or no? Yes. So what I will do, I will equate this to 0. What you will get? You will get x equal to minus 3. Next I will equate this to 0. I will get x equal to 7. I will mark them on the number line. You see here as per this order, right? Now less than 0 is there. Now here you observe here less than 0. Less than 0 means you need to look for negative sign. You see here negative sign here. That means if you take any x value in this interval, here this is strictly less than is there again. That means minus 3, 7 we won't consider. You take any number in this interval, this red color part is there. You take any x value in this interval and substitute in this, 100% it satisfies. For example, in between minus 3 and 7, 0 is there. 0 plus 3 is 3. 0 minus 7 is minus 7. 3 into minus 7 is negative. Satisfying. I hope you are understanding. Suppose if the question is like this, then what is its solution? Its solution for this inequality is open interval minus 3 to 7. Here they given strictly less than. That's why this is open interval. For the same question, if they given less than or equal to, then we will write closed interval minus 3 comma closed 7, right? Okay, so successfully we completed first problem. I hope you understand this, right? We will move to next question. You observe this question. What is there here? 2 minus x into x minus 5 greater than or equal to 0 is there. Here one problem is there. See here, this is not like x minus a form. This is like a minus x. But this can be written in the form of a minus a. We can write in the form of x minus a just by taking minus common. Okay. So what I will do here, I need to solve this inequality. First point what I observed here, if you observe this is not in the form of x minus a. But however we can write. Okay. See here, first I will write the given inequality. 2 minus x into x minus 5 greater than or equal to 0. This is the given inequality. I want to solve this inequality. As here x minus a is not there, I want to write this in the form of x minus a or x plus a. What I will do, I will take minus common. See, you know that 2 minus x can be written as minus of x minus 2. Minus, if we take common, 2 minus x can be written like this. Okay. So here minus of x minus 2 into x minus 5 greater than or equal to 0. Now this is the inequality. You observe here minus sign is there now. What I will do, this complete inequality I will multiply with minus 1 on both sides. This complete inequality I will multiply with minus 1 on both sides. In the rules of linear inequalities, in last class you learned that for an inequality, if we multiply with a negative real number, the sign of inequality changes. Here greater than or equal to is there now. If we multiply with negative real number, this greater than or equal to changes to less than or equal to. So what you will get here, this will become x minus 2. I am multiplying with minus. When I multiply with minus, minus will become plus. X minus 2 into x minus 5 is less than or equal to 0. What happened here? This greater than or equal to change it to less than. Why? This inequality, both sides I multiplied with minus. When I multiply with minus, minus minus will become plus. Here minus 1 into 0 is 0 only. I hope you understand. In rules of inequality, we learned that for an inequality, if you multiply with a negative real number, the sign of inequality changes. That's why greater than or equal to changes to less than or equal to. Now if you observe this came into that our regular form, x minus a into x minus b form is there, that form we got. Now what we'll do, we'll equate this to 0, you will get x equal to 2. Next we'll equate this to 0, we'll get x equal to 5. So 2, 5 we'll mark on the number line, see here, this is 2, this is 5 as per number line order. Wavy curve method says that in the rightmost corner you keep plus and then alternate symbols. Okay. Now actually we are solving this actually, right? Here what sign is there? Less than 0. Less than 0 means we need to look for positive sign or negative sign. Less than 0 means we need to look for negative sign. That means where is the negative sign? Here is the negative sign. So when you take any x value in this interval, 100% this inequality holds good, right? What I'll do here, what is the interval x belongs to? You see here less than or equal to is there. When less than or equal to given, then all these things also will consider. Like what we'll write it as x belongs to closed interval 2, 5. You take any number in this interval. For example, in this interval 3 is there now. That 3 you substitute in this question. That 3 substitute in this question. It 100% satisfies. 3 you substitute 3 minus x. 2 minus. I'll write here 2 minus 3 into 3 minus 5. What problem is that? Okay. Substitute 3 in this. What you will get? 2 minus 3 into 3 minus 5. This is negative. 3 minus 5 is also negative. Negative into negative positive. See here greater than or equal to 0 is there. I hope you are understanding what I am trying to say. You take any number in this interval, that is the solution of this inequality. It means if I substitute any number from this interval in this inequality, it 100% satisfies. So that's why for this linear inequality, solution is closed interval 2, 5. I hope you are understanding. Now we'll move to next problem. You observe this question. Here actually product of 3 linear factors are there. Actually x can be written as x minus 0, right? Let's solve this solution for this. Okay. This x is there, that can be written as x minus 0, right? X minus 2, x plus 3. Now we need to find what are the x values satisfies this inequality. These are already in x minus a, this is x plus b form, it is okay, right? This is in correct form only. You equate this to 0, you will get x equal to 0. You equate this to 0, you will get x equal to 2. You equate this to 0, you will get x equal to minus 3. Okay, what I'll do, I'll mark these things on the number line. Okay, first one is what? 0. I'll get here somewhere. X equal to 2. X equal to 2 you will get here minus 3, x equal to minus 3. As per number line order only you need to mark 0 to minus 3 are getting marked like this. Now in the rightmost corner, wavy curve method says that rightmost corner you keep plus and then alternate symbols. Now what I want greater than 0. Greater than 0 means you need to look for positive sign or negative sign. You need to look for positive sign. Where is this positive sign? See, in this interval, right? So if I take any number in this intervals, 100%, if you take any number in this interval, 100% those numbers satisfies this inequality. So how you will write the solution? X belongs to, you observe here, greater than or equal to is there. When greater than or equal to is there, these numbers also we will consider, right? So what you will get? Closed interval minus 3 to 0 union closed interval 2 to infinity. Why closed interval? Because this is greater than or equal to is there here. So if you take any number in this interval, if you substitute in this inequality, it satisfies. That's why this is solution of this inequality. I hope you are understanding. You see this question, x into x minus 5 greater than or equal to 6. We need to solve this inequality. Here one problem is there. You see, actually whatever I written here, if the here see greater than 0, less than or equal to 0, right hand side part 0 is there, you observe, right? But in this question what happened? In this question you see here greater than or equal to 6 is there, right? Then how to solve this? Okay, basic thing is we can convert this in the form of x minus a into x minus b, or x plus a into x plus b, or x minus a into x plus b. Like this we can convert. Okay, so what I'll do here was simplify. See, first you take the given question. What is the given question? X into x minus 5 is greater than or equal to 6. Okay, left hand side part you multiply what you will get. X square minus 5x is greater than 6. Okay, now what I'll do, I'll take this 6 is there, I'll take 6 to the left hand side part. Actually we cannot take like this, we are subtracting 6 on both sides. For an inequality, if we add or subtract any real number, the sign of inequality remains same, you know that. Okay, so what this will become, x square minus 5x minus 6 here greater than or equal to is greater than or equal to 0. Okay, now you see this is a quadratic expression, right? We can split the middle term, right? See here, x square minus 5x minus 6 is there. You split the middle term. Minus 5x can be written as minus 6x plus 6 minus 6, right? This can be written as x minus 6 into x plus 1. Okay, so here x square minus 5x minus 6 is there, that can be written as x minus 6 into x plus 1 greater than or equal to 0. Now you see we got that general form like x minus a into x minus b. From this you can do this very easily, right? Yes, how you will simplify further? See, equate this to 0, you will get x equal to 6. Equate this to 0, you will get x equal to minus 1. Mark them on the number line. 1 is minus 1. Okay, another one is 6. In the rightmost corner you write plus and then alternate symbols. Here what sign is there? Greater than or equal to 0. Greater than or equal to 0 means you need to look for positive sign, correct? Okay, that means which part? You observe here positive sign. Here this zone. Here greater than or equal to is there. Greater than or equal to is there. That means these points are also included. How you will write this answer? We will write like this. X belongs to, for infinity always open bracket, right? As greater than or equal to is there. That's why closed interval minus 1 union closed interval 6 to infinity. If you take any number in this interval, if we substitute in this, it 100% satisfies, right? I hope you understand this first type in this wavy curve method. In second type, what we will learn here, suppose same thing is there. If x 2 minus x whole square is there, or else in this form, here x minus 2 whole square is there, here x plus 2 whole cube is there. In that case, how you will solve these linear inequalities? You can take a look of these 5 problems quickly. This is one problem. You see here 2x plus 1 is there. This is also comes under type 1 only. Here minus 2x plus 1 is there. Then how we will solve? And here you see here square, in case if powers are square, cube is there, then how to solve it, right? Here you see in the power square is there, cube is also there, then how to solve this inequality? So these are the problems we are going to solve in this class. Okay, come to this inequality, 2x plus 1 into x minus 5 greater than or equal to 0. Here I said that these must be linear factors. Actually these are linear factors. If x coefficient is 1, it is good to simplify further. Otherwise, we can make x coefficient 1. We will make x coefficient 1. Here, as x coefficient is 2, directly also you can do. But as you are new to this inequalities, let's see how to solve this problem. What I want the given inequality must be in this form, x minus a, x minus b, or x plus a, x minus b of this form. Okay. Now what I'll do, here 2x plus 1 is there, I'll take 2 common. You take 2 common. What you will get if you take 2 common? This will become x plus 1 by 2. Okay. So if you multiply these two, again you will get 2x plus 1 only into x minus 5. Okay. Into x minus 5 is greater than or equal to 0. Now you see x coefficient is 1 now, right? As 2 is there here, both sides I'll divide with 2. So then what happened? This 2 will get cancelled. 0 divided by 2 is 0. For an inequality, if you divide with a positive real number, the sign of inequality remains same, that you learned in rules of inequalities. So here, what is the next step I'll get? When I divide this inequality with 2 on both sides, I'll get like this. X plus 1 by 2 into x minus 5 is greater than or equal to 0, right? Now you see, now I got this side form is in the form of x plus a into x minus b. So I can use wavy curve method here very easily. Okay, so what I'll do now, draw the number line. Now you equate this to 0. What you will get? You will get x equal to x plus 1 by 2 equal to 0. X equal to minus 1 by 2, right? That minus 1 by 2 you mark on the number line. Similarly, you equate this to 0. You will get x equal to 5. So mark these two numbers on the number line. One is what? Minus 1 by 2. Another one is what? 5. Now in the rightmost corner you keep plus and then write alternate symbols, minus, plus, like this. Now here which sign we are looking for? See here, greater than or equal to 0. See, whenever greater than or equal to, here or equal to is there. Now this is not strictly greater than or equal to. In that case, we will consider these numbers. You see here, what I'll do, I'll highlight this. This 5 is also included and minus 1 by 2 is also included. Now what you are looking for? You are looking for greater than 0. Greater than 0 means you are looking for positive sign, right? So positive sign, you see here, this part is the solution. As greater than or equal to is there, this 5 and minus 1 by 2 is also included. So what is solution of this inequality? X belongs to, that shaded part is there na, yellow color one, minus infinity to minus 1 by 2. As here greater than or equal to symbol is there, this is closed bracket, okay, union 5 to infinity. See, whatever this yellow color part is there, na, that is the solution of this inequality. Here what you learn here, in this interval you take any number, if you substitute in this inequality, it will definitely satisfy, right? I hope you understand. We calculated solution of this inequality, right? So how you will get this? Solve for x this inequality or solve this inequality, like that they'll ask in exam. Okay, now we'll move to next question. Here the point is, see here, x coefficient is not 1. Okay, so what I'll do, I'll try to make x coefficient 1 by taking minus 2 common. What I'll do here, I'll take minus 2 common. You take minus 2 common. If you take minus 2 common, what you will get? You will get x minus 1 by 2, right? You know how to take this common. See, if you multiply these two, what you will get? Minus 2x. If you multiply these two, minus of minus plus 2 into 1 by 2 will become 1 only, into x minus 3. X minus 3 is less than or equal to 0. Now, you see here, this is of the form x minus a into x minus b. Here no problem is there. Actually, the problem is coming with this minus 2 here. As what I want here, I'll divide this complete inequality with minus 2. As minus 2 is negative real number, for an inequality, if we divide with a negative real number, sign of inequality changes. That means this less than or equal to is there, na? That changes to greater than or equal to. So divide both sides with minus 2. Then this minus 2 will get cancelled. Right hand side part 0 only. So you see what happens here. This is x minus 1 by 2 into x minus 3 greater than or equal to 0 divided by minus 2 is 0. I hope you understand this. As for this inequality, I divided with minus 2 on both sides. This sign is then less than or equal to. That changes to greater than or equal to. Now you can see this is in the form of x minus a into x minus b only. So equate this to 0, you will get x equal to 1 by 2. Equate this to 0, you will get x equal to 3. Okay. X equal to 1 by 2. Mark it on the number line. X equal to 1 by 2. Next, x equal to 3. Now you observe here, greater than or equal to is there. Na? So what will happen? This 1 by 2 and this 3 is also included. Now in the rightmost corner, you write plus. And then alternate symbols. Wavy curve method says that in the rightmost corner you write plus and then alternate symbols. Okay. Now what we are looking for? We are looking for this greater than or equal to 0. Greater than or equal to 0 means positive sign, right? Greater than or equal to 0 means positive sign, right? This is this yellow color part is there. Na? That is the required solution. Greater than or equal to symbol is there. These points are also included. Okay. So what is the solution for this? X belongs to minus infinity to closed 1 by 2 union closed 3 to infinity. I hope you understand the solution of this problem. Okay, now we'll move to next problem. You see this problem here, 3x plus 2 is there, x minus 1 whole square is there, x minus 4 less than 0. What the point is, we need to solve this inequality. For what values of x this inequality holds good? That is the question. Here, you see here, this is not like x minus a or x plus a or x minus b type. X coefficient 3 is there. As 3 is positive, directly you can do this. However, best thing is you try to make x coefficient 1 so that you can simplify this very easily. Okay, right. You take 3 common here to make x coefficient 1. You take 3 common. Okay, if you take 3 common, what you will get? X plus 2 by 3. Okay, into x minus 1 whole square into x minus 4 less than 0. Now, here 3 is there. Na? As 3 is positive, it is not a big problem. You divide with 3 on both sides. As 3 is a positive number, the sign of inequality remains same. This side 3 will get cancelled. So what I'll get here, I'll get x plus 2 by 3, x plus 2 by 3 into x minus 1 whole square into x minus 4 less than 0. Now the point is, for what values of x this inequality holds good? And from this problem onwards, it's a type 2 problems. See, till now, whatever first 6 problems we did, they are all like type 1 problems. Type 2. Why this is type 2? In the powers, if square is there, square, cube, something is there like that, then how to simplify? Okay, this is type 2 problems. Now, you see here, whatever x value you take, whatever, this is even power, na? Whatever x value you take, this x minus 1 whole square is clearly greater than or equal to 0. Whatever real x value you take, x minus 1 whole square is greater than or equal to 0. So here, equal to 0 is not there. Na? When this will be equal to 0? When we take x equal to 1. Right? Whatever real value you take other than 1, this expression is clearly positive. Clearly positive. If you observe this whole thing is negative. This whole thing is negative. This is positive. As this is positive, what I can write here, x plus 2 by 3 into x minus 4 is negative. As this is positive, if this whole thing is negative, then this whole expression is negative. If you understand this, you can proceed like this. In case if you didn't understand this, for that also easy method is there. What is that easy method? See, you equate this to 0. Right, what you will get, minus 2 by 3 you will get. Mark that minus 2 by 3 on the number line. Okay, now you equate this to 0. You will get x equal to 1. Number line order only, right? X equal to 1. You mark it. Now you equate this to 0. You will get x equal to 4. Okay, in the rightmost corner you write plus. Now you see here, this 4 is there. Now this 4 is coming from this. You observe the power of this. Here nothing is there, means power 1 will be there. If odd power is there, then sign changes. Odd power. 1 is odd number. Na? If odd power is there, sign changes. Here plus is there, na? Plus changes to minus. Right? Now you see here 1. 1 is coming from this. This 1 is coming from this. Here what power is there? Even power is there or odd power is there? Even power is there. When even power is there, sign won't changes. Here minus is there. Na? That minus remains minus only. That minus remains minus only. Right? Now come to this. Minus 2 by 3. Minus 2 by 3 is coming from this. You observe what power is there? Odd power is there. See, when odd power is there, the sign changes. Here minus is there, na? That minus changes to plus. Okay. You write like this. With little bit of practice, you can easily do these things. These are not big confusing things actually. Little bit of practice is needed. That's it. Now, what sign you are looking for? You are looking for less than 0. Less than 0 means positive sign or negative sign. You are looking for negative sign, right? Here it is strictly less than is there. Strictly less than is there. When strictly less than is there, these points we won't consider. See, here, when strictly less than is there, these things we won't consider. If less than or equal to is there, then we'll consider, we'll mark a dark circle here. As I written open circle, that means these points are not included. So less than 0 means which sign I want? I want negative sign. See, this shaded part is there, na? That shaded part is the solution. So what I can write here, the solution is x belongs to open interval, because it is strictly less than, open interval minus 2 by 3 to 1 union 1 to 4. I hope you are understanding, right? Here, I just want to tell you the other method here after this step. As you know that here strictly less than is there. This is clearly positive. This is clearly positive for any real x value. This is clearly positive. Chance of 0 is also there. X equal to 1 I take, then in that case x minus 1 whole square will become 0. As this is clearly greater than or equal to 0, after this step I can write like this. Observe this carefully, please. Right. What I can write after this step, I can write like this. Another method I am explaining. X plus 2 by 3 into x minus 4 is less than 0. I hope you are understanding what I am saying. Now, see here, this is less than 0. You see, as I came to know this is positive, this must be negative. Then only this whole thing is negative. Positive into negative is negative. Okay. So what I'll do here, I'll mark a number line here, minus 2 by 3, here 4, rightmost corner plus, minus, plus. Alright. Now I'm less than 0 means negative sign. Where is the negative sign? Here, minus 2 by 3 to 4. Here, as strictly less than is there, when I take x equal to 1, in this interval 1 is there, minus 2 by 3 to 4, 1 is there. If I take x equal to 1, this inequality fails. That's why from this interval, I need to remove 1, minus 2 by 3 to 4, minus 1. This also same only. Both are same only. I hope you understand the solution. You can do in that method also, but however, this is the thing without confusion. You can do it. In case if you are worried about these signs, why these signs are not changing, in case if you are worried like that, then what method I said, that is also another method is there. See, with practice you will come to know all these things. Okay, now we will move to next question. You see here, this is type 2 wavy curve method only. X minus 1 whole square into x plus 1 whole cube into x minus 4 less than 0. We need to find x values which satisfies this inequality. Okay. So all x coefficients 1 only here. So no worries. Directly you mark the number line. Okay. On the number line, first you equate this to 0. You will get x equal to 1. Okay. X equal to 1 means somewhere here I will mark this is 1. As per number line order, you equate this to 0. You will get x equal to 4. If you equate this to 0, you will get x equal to minus 1. See, number line order, first negative number, next 1, next 4, like that. Now, wavy curve method says that in rightmost corner you write plus. This is plus always. Rightmost corner you write plus. Now, here 4 is there. Now, this 4 is coming from this. Here, what is the power? Power 1 is there. Odd power is there. When odd power is there, then sign changes. This plus changes to minus. This plus changes to minus. Okay. Now, this, look, this 1 is coming from this. 1 is coming from this. Here what power is there? Even power is there. When even power is there, sign own changes. That means here minus is there, na? Here also minus you will write. This is wavy curve method. If you do this in regular method, it is very difficult actually. Okay. Now, minus 1 is there here. Minus 1 is coming from this. Here what power is there? Here odd power is there. When odd power is there, this sign changes. Here minus is there, na? Minus changes to plus. Okay. Now finally, you come here, strictly less than is there. Na? When strictly less than is there, in that case, we won't consider, we'll write open circle. That means these points are not included. 1, 4, minus 1 are not included. Less than 0. Here see, less than 0 means we are looking for negative sign. Where is the negative sign? See, this yellow color part is there. Na? This part is the required solution. So what you will get here, that x is open interval minus 1 to 1 union 1 to 4. This is solution of this inequality. If you take any x value in this interval, if you substitute in this, 100% it satisfies. See, these inequality problems are easy actually, but we use them very frequently while especially relations and functions are whenever inequalities comes to solve the inequalities, this wavy curve method is very useful, right? We'll move to next one. You see here, x minus 2 whole square into x minus 3. Here x coefficient is 1 only. So directly on the number line we'll mark number line. Okay. Now equate this to 0, you will get x equal to 2. Okay, mark 2, right. Equate this to 0, you will get x equal to 3. Mark 3 on the number line. Now in the rightmost corner plus. You see here this 3 is coming from this, right? What power is there? In here odd power is there. When odd power is there, sign changes. This plus changes to minus. Yes, plus changes to minus. Now you see this 2. 2 is coming from this. Here what power is there? Even power is there. When even power is there, sign won't changes. Sign won't changes, right? So here this minus remains minus only. Now here less than 0 is there. Less than 0 means which sign we are looking for? We are looking for negative sign. Okay, so x belongs to minus infinity to 2. Okay, here 1 point strictly less than is there, no? That's why we won't include these points. That's why this is dotted circle. If we mark this less than 0 means we want this, right? Union, open interval 2 to 3. So this is the solution of this inequality. If we take any x value in this interval, if we substitute in this, it 100% satisfies. If you have any doubt, you can check. For example, in this interval 0 is there. In this interval 0 is there. Yes, 0 is there in this interval. Substitute 0 here. 0 minus 2 whole square. This is positive, correct? 0 minus 2 whole square is positive into 0 minus 3. 0 minus 3 is negative. Positive into negative is what? Positive into negative is negative. See here less than 0. Satisfying. 0 satisfying. Like that. So many values are there in this interval. All the values satisfies this inequality. I hope rational inequalities. How to solve rational inequalities? You know rational function. Rational function means what? A function which is in the form of f of x divided by g of x, where f of x comma g of x are polynomial functions. You observe here, this is like f of x divided by g of x. Here, as inequality is there, this we call it as rational inequality. You see here, this is also one rational inequality. Here, in the numerator, denominator, linear factors are there. Right? What about this one? Is it a rational inequality or not? Yes, because it is in the form of f of x divided by g of x. And here you see, here linear factors are not there. It's not a problem. We can split the middle term. We can write this quadratic expression into linear factors. Okay. So in this class, we will learn how to solve this rational inequalities with the help of wavy curve method. Okay. So before going to start this video, please drop a like for this video and share it with your friends. In case if you are not yet subscribed, subscribe now. Let's start the class. Okay, here in rational function, one thing you need to observe. Here, whatever this denominator part is there, this denominator part cannot be equal to 0. If this denominator part is 0, what happened? This total function is not defined. Okay, so you make sure that whatever x values you will find, for those x values, denominator cannot be equal to 0. That is the only point you need to keep in your mind. You see, we need to solve this rational inequality. It is in the form of f of x by g of x. The procedure is same. How we learn in type 1, type 2, same procedure. But the only thing you need to consider that this denominator cannot be equal to 0. You keep that denominator cannot be equal to 0. At the end, see how we learn in wavy curve method in type 1, type 2, same procedure will follow, but at the end, for what values x minus 2 is 0, those x values will remove. That means we need to make sure that whatever x values we will get, for that this x minus 2 cannot be equal to 0. Okay, so come back to that wavy curve method. Here linear factors are there. Very good. Now what we'll do, first we'll one number line, right? Take a number line. Now equate this part to the 0. You will get one x value. What is that x value? X value is minus 1. You mark it on the number line as per number line order, minus 1. Now equate this to 0. You will get x equal to 2. Okay. Now here you see less than or equal to is there. Less than or equal to is there means generally in type 1, type 2, we will consider these parts also, these numbers also, minus 1, 2 also we will consider. Here as denominator cannot be equal to 0. See, if x equal to 2, what is denominator? Denominator will become 0. So x cannot be equal to 2. As here less than or equal to is there, generally what we'll do, we'll consider these two. We'll use a dark circle here. But as it is a rational function, this denominator cannot be equal to 0. So what I'll do here, listen carefully. I'll consider this minus 1 because minus 1 is in the numerator. Minus 1 is a part of the solution. But when it comes to 2, 2 is not a part of the solution. Open circle. Open circle means 2 we are not considering. Okay. Now look at this. Less than 0. Less than 0 means we need to look for... now one more thing. In the rightmost corner you write plus. Wavy-Curve method says that in the rightmost corner you write plus and then alternate symbols. Okay. Now less than or equal to 0. Less than or equal to 0 means we need to look for which sign? Positive sign or negative sign? We need to look for negative sign. Less than 0 means. Where is less than? Here you see this is less than is there. So you just see, you observe this yellow color part. Whatever the solution, whatever that yellow color shaded part is there, that is the solution of this inequality. It's very simple. See how we done these methods, these problems we done earlier. How we solve these inequalities. Same procedure we will follow, right? Procedure is same, right? Okay. Now what is the solution? What is the solution? X belongs to closed minus 1, open 2. This is the solution of this inequality. If you substitute whatever x value is there in this interval, all those x values satisfies this inequality. For example, in this interval 0 is there. In this interval 0 is there? Yes, 0 is there. 0 you substitute in this, it definitely satisfies this inequality. I'll check here. 0 plus 1, 1 divided by 0 minus 2, minus 2. This is less than 0. Yes or no? Yes. So 0 is satisfying. I hope you are understanding. In rational function, only the thing you need to observe that we need to remove those x values. For those x values, denominator is 0. Okay. Right. I hope you understand this solution. Now we'll move to next question. You observe this question, what they are asking. Solve this linear inequality. Here it is a rational function because it is in the form of f of x divided by g of x. Here the point is, you see, these are all linear factors. These are all linear factors. Here x is there, na? This x can be written as x minus 0. Follow the regular procedure. Make sure that denominator cannot be 0. That means you consider these points. In denominator here x is there, na? This x cannot be 0. I'll write here. I'll keep this in my mind. X cannot be 0 and x plus 2 cannot be 0. X plus 2 not equal to 0 means x cannot be equal to minus 2. Right? I'll write that also. X cannot be equal to minus 2. Okay. X cannot be 0 and x cannot be minus 2. Right. Now, as these are the linear factors, you can start marking these on the number line. Okay. First, I'll equate this to 0. X can be written as x minus 0. X minus 0 equal 0 means x equal to 0. Okay. Mark 0 in the center. As per number line order, you need to mark. Now, if I equate this to 0, what I'll get? X equal to minus 2. Okay. Mark it minus 2. Minus 2 somewhere you will get here. Now, equate this to 0, what you will get? X minus 1 equal to 0 means x equal to 1. Okay, you will get x equal to 1. Now equate this to 0, what you will get? You will get x equal to minus 5. Okay, mark it as per number line order. Okay, now Wavy-Curve method says that in the rightmost corner you write plus and then alternate symbols. Okay, now while proceeding further, you see here greater than or equal to 0 is there. Greater than or equal to 0 means generally we will consider all these points that you learn in type 1, type 2. Okay. But here denominator cannot be equal to 0 na. So what I will do, you see here x cannot be equal to 0 na. X cannot be equal to 0. At 0 in the beginning only I'll one open circle. Open circle means this 0 is not included. And x cannot be equal to minus 2. So at minus 2 also I'll write one open circle. Okay. Here now what is that? Greater than or equal to 0. Greater than or equal to 0 means which sign you need to look for? You need to look for positive sign. Okay. So positive sign. Okay. Positive sign. You see here this part. 1 is a part of the solution because this is greater than or equal to. 1 is a part of the solution. So at 1, just dark circle means 1 is included in the solution. Now next plus sign, we are looking for plus sign. Where is the next plus sign? Here you see, as we already mentioned that minus 2, 0 are not included because as they are in the denominator. Okay, next plus sign, where is it? You look here also plus sign is there. Next plus sign is there here, right? Now minus 5 is included or not? Here less than, greater than or equal to is there. So here this minus 5 is included. This minus 5 is included. So this, you observe, this is open circle. These numbers are not included. Dark circles are included, and this yellow color part is there. Now that is the solution. Now how to write the solution? X belongs to minus infinity to 5 is minus 5 is included. That's why closed interval. Union. You see here minus 2 is not included, 0 is not included. So that's why open interval. Open interval minus 2 to 0. Union. Yes. Here 1 is included. That's why closed interval 1 to infinity. See, these problems are actually very easy. Little bit of practice is needed. You need to practice some problems. Once you get an idea, then you will get confidence of doing all these things, right? So this is the third class. This is third class in linear inequalities. In first class, we discussed what are intervals, what is closed interval A, B, open interval A, B, what are the rules of inequalities, and we done some problems in first class. In second class, we learned wavy curve method introduction. In that type 1 problems we did, type 2 problems we did, right? So this is fourth class actually. We are doing rational inequalities. Okay. If you do some problems your own, then obviously you will come to know, right? Okay. These problems are not so difficult, but only thing is practice is required. That's it. Now you see this question, solve this inequality. You see here the rational functions are there, but a little bit of simplification is needed. So what I'll do, first I'll simplify the given function. See what they given here, x divided by x plus 4 is less than or equal to 1 divided by x plus 1. Okay. You take this 1 divided by x plus 1 to the left hand side. It is nothing but just subtracting. Okay. So if you subtract, nothing, inequality sign remains same only. No need to worry about inequality sign. Minus 1 divided by x plus 1 less than or equal to 0. Now I'll simplify this part. Simplify. What you will get here? Here LCM is x plus 4 into x plus 1. Okay. Now you simplify numerator part. What you will get? X into x plus 1. X into x plus 1 is what? X square plus x. You can understand this. X into x plus 1 is x square plus x. Minus 1 into x plus 4. Then what you will get? Minus x minus 4 you will get, less than or equal to 0. Right? Now plus x minus x will get cancelled. What is there in the numerator? In the numerator, x square minus 4 is there. X square minus 4 can be written as, see, x square minus 4. X square minus 4 is there. Now this 4 can be written as 2 square. So this is x plus 2 into x minus 2. Right? So numerator is what? Numerator is x plus 2 into x minus 2. Okay. Divided by x plus 4 into x plus 1 less than or equal to 0. I simplified this inequality. I got like this. Now this is a rational function. You observe your linear factors are there. As linear factors are there, now we can go with the direct number line method, right? Now what I'll do, I'll mark these numbers on the number line. Okay. Now make sure that denominator cannot be equal to 0. If I equate this to 0, x cannot be equal to minus 4. Note down that x cannot be equal to minus 4. If x equal to minus 4, what is happening? Denominator is becoming 0. And x cannot be equal to minus 1. X cannot be equal to minus 1. Okay. Now mark these things on the number line. X plus 2 equal to 0. What you will get? X equal to minus 2. Okay. X equal to minus 2. Mark minus 2. Yes, x equal to minus 2. Equate this to 0. You will get x equal to 2. Okay. X equal to 2. Okay. Next, equate this to 0. You will get x equal to minus 4. Minus 4 means on the number line you will get here. Okay, equate this to 0, you will get x equal to minus 1. Minus 1 means here you will get on the number line. Okay, now rightmost corner, Wavy curve says that rightmost corner you keep plus. Okay, I'll keep plus in the rightmost corner. Okay, I'll keep plus in the rightmost corner. Now alternate symbols, plus, minus, plus, minus, plus, like this. We need to extend this. Okay. Okay. Now here you observe this. Denominator is there, minus 4 is there. Minus 4 we cannot include. Minus 1 also we cannot include. In the beginning only, what I'll do, I'll write one open circle. What is happening here? Right here, one open circle. That means minus 4 is not included. At minus 1 also, I'll write one open circle. That means minus 1 is not included. Okay. Here what sign is there? Less than or equal to 0. Less than or equal to. Equal to. Less than or equal to is there. That means whatever other numbers are there, we'll consider that. That means minus 2 is a part of the solution. Plus 2 is also part of the solution. Now less than 0 means we need to look for negative sign. Negative sign. Where is the negative sign? You see, this is the negative sign. Here it is the negative sign. Okay. Now what is the solution? The solution is x belongs to open interval minus 4 to minus 2. For minus 2, closed interval or open interval? Here less than or equal to is there. That's why minus 2 is included, right? So what you will write? Closed interval. Union. Union. Next, for this part we need to write. Here open circle is there. That means open bracket minus 1 to closed to. This is solution of this inequality. If I substitute any x value from this interval in this inequalities, it 100% satisfies. If you want, you can see these problems are easy. What the things are required? Your practice. First thing, you learn the things from the class and then you please practice. That's it. Okay. This problem is important. Many students they'll confuse in this because this problem won't come like this. See, this part is there. You observe here. This part is there. Here powers are there. They are all odd powers are there. It's a linear factor. Suppose here 2 is there. If 3 is there, here 2 is there. Then how we will solve? Those things will come in this problem. So this problem is important. You watch till the end to get the clarity in this. Okay. So if you are already good in type 2 wavy curve method, you can start doing these things. Okay. Okay. Now what I'll do here first, I'll simplify this, right? In the numerator, you can observe here, in every term x square is there. I can take x square common. In the numerator, you take x square common. Then what you will get? X square minus 3x plus 2. That you will get in the numerator divided by denominator. See, denominator, I will split the middle term. You know how to split the middle term. Here, minus x is there. That minus x can be written as minus 6x plus 5x. Yes, minus 6x plus 5x is minus x minus 30. Yes, it satisfies. So, split the middle term. Okay, so what I'll write here, x square minus 6x plus 5x minus 30 is greater than or equal to 0. Now, here you split this middle term. This can be written as a minus 2x minus x, right? So, x square into, if you split the middle term, what you will get here? I think you will get x minus 1 into x minus 2. Yes, you will get x minus 1 into x minus 2. You know how to split the middle term, right? That's why I'm not doing separately this. Okay, divided by here. This is there. If you split the middle term, if you write into linear factors, you will get like this. X minus 6 into x plus 5 you will get. By seeing this, you can easily say minus 6x plus 5 is there. So you will get like this. Now, what is the problem of doing this here? This is x minus 0 whole square. See, x square can be written as x minus 0 whole square. Even power is there here. There you need to be cautious. Other than that, this problem is easy. Okay. So what I'll do, now I'll go with a number line. Okay, I'll mark a number line here. On the number line, you mark these points. Here, x minus 0 whole square, when you equate this to 0, you will get x equal to 0. Mark 0, okay. Equate this to 0, you will get x equal to 1, okay. Mark 1. Now, equate this to 0, what you will get? You will get x equal to 2, okay. X equal to 2. Now, Here denominator part, you observe, you equate this to 0, you will get x equal to 6. Okay, equate this to 0, you will get x equal to minus 5. Minus 5 you will get here, this is minus 5. Okay, now rightmost corner means this part. In this part you write plus first. Wavy curve method says that in the rightmost corner you write plus. Okay, I'll write plus. Afterwards, here 6 is coming from this. In the power of this, 1 is there, 1 is odd power. When odd power is there, sign changes. Why this is following? Because here even power is there in this. That's why we are checking these things. Okay. When odd power, see what I am trying to say, this 6 is there now. The 6 is coming from here. Here 1 is there now. 1 or any odd power is there. In that case, sign changes. Plus changes to minus. Okay. Next, this 2 is there here. 2 is coming from what? Here. 2 is coming from this. Here 1 is there. 1 is odd power. When odd power is there, sign changes. Minus changes to plus. Very good. Now, here 1 is there. 1 is here, right? Here what power is there? Odd power or even power? Nothing is there means 1 will be there. This is odd power. When odd power is there, sign changes. Plus changes to minus. Okay. Here 0 is there. 0 came from this. You observe here. Here even power is there. When even power is there, sign won't changes. Here minus is there, na? Minus remains minus only. Okay. Now here minus 5 is there. Minus 5 came from this. Here odd power is there. So sign changes. After that, as this part is in the denominator cannot be equal to 0. So that means x cannot be equal to 6. What I'll do here, I'll at 6 open circle. That means 6 is not a part of the solution. And x cannot be equal to minus 5. Right? At minus 5 also, I'll mark one open circle. Now, here greater than or equal to is there. You observe here greater than or equal to. That means all these points are included. So, we'll highlight these things. These are included. These are included. Okay. Now, what sign it is greater than 0? Greater than 0 means positive sign. We need to look for positive sign. Observe this. This is the part of the solution. Here, yes, 1, 2 also included. Next positive is there here. Right? So, what is the solution? The solution for this is, I'll write here. The solution for this is x belongs to, okay, minus infinity to minus 5 is not included. So, for minus 5, it's a open, for minus 5, it's a open interval. Okay. Union. See, 1, 2, both are included. 1, 2, both are included. That means closed interval 1, 2. Union. You observe this. Open interval 6 to infinity. Open interval 6 to infinity. 6 is not included. Open interval 6 to infinity. See, one thing we missed here. What is that? See here, 0, 0. We missed 0. See, when I put x equal to 0 in this, what happened? This whole thing is becoming 0. Here equal to 0 is there, right? So you need to be very careful while writing these answers. Okay. So what you will write here, and you need to include, I'll write union 0, singleton set 0. So this is the solution of this inequality. If we take any x value in this interval, if I substitute here, it 100% satisfies. I hope you understand wavy curve method. Total 3 types we learn. Now onwards, what are the problems we will do? They are just practicing these inequalities, how to solve the inequality, whether it is wavy curve method or another method. You see this problem, in this class, we are going to do 3 important problems. You see this one. Here, see powers 2, 3, 2, 1 is there, right? And even though if they give that higher numbers in the powers like this, then also we can solve it easily. These 3 problems we are going to do in this class. Okay. So, first point, observe what they are asking, solution set. That means we need to solve this inequality. Okay. So, what I'll do here, first I'll write what is the given inequality. What is the given inequality? X into x plus 2 into x minus 3 whole square is less than or equal to 0. If you observe this, these are all linear factors. So, no need of any simplification further. Linear factors, correct? Okay. Now, here less than or equal to is there. As these are linear factors, What I'll do now, directly I'll equate this to 0. X can be written as x minus 0. If I equate this to 0, I'll get x equal to 0. Equate this to 0, you will get x equal to minus 2. Equate this to 0, you will get x equal to 3. Now, you mark these things on the number line. Okay, what are the numbers? First one is 0, okay. Next one is 3, okay. Next one is minus 2. Now, the wavy curve method says that in the rightmost corner, you keep plus, okay. I'll keep plus here. I'll keep plus here, okay. Now, you observe this 3 is coming from this, okay. You observe here, this 3 is there, now this 3 is coming from this linear factor. In the power of this linear factor, even number is there. In type 2 models, we learn when power is even number is there, the sign doesn't changes. It remains same. Here plus is there. Na? This again also plus will come. Because this 3 is coming from this, its power is even power is there. This sign won't changes. Right? Here plus only. Now you observe this 0. 0 is coming from this. This is actually x power 1. When odd power is there, then sign changes. This plus changes to minus. Okay. Now you observe this minus 2. Minus 2 is coming from this. What is the power here? Odd power is there. When odd power is there, sign changes. Here minus is there, na? Minus changes to plus. Okay. Sign changes like this. This we already discussed in earlier classes also. As they given here less than or equal to, these numbers are also part of the solution. Okay. So here less than 0 is there. Less than 0 means negative sign. We need to look for negative sign. Where is the negative sign? You observe here. Here is the negative sign. That's it. This much only. Negative sign. Okay. So I'll write its solution. Observe carefully. X belongs to, as less than or equal to is there. This 2 is also part of the solution. I'll highlight this. 2 is also part of the solution. 0 is also part of the solution. Okay. X belongs to closed interval minus 2 to 0. Minus 2 is included. 0 is also included. Why? Because in place of x, if you write minus 2, you see this whole thing will become 0. As this is 0, this whole thing is 0. Here equal to 0 is there, na? Right? 0 is also included. Here 0 is a part of the solution. In place of x, if you write 0, this whole thing will become 0. Here equal to 0 is there, na? That condition holds good. Here you cannot miss this 3. You cannot miss this 3. Why? Because here equal to less than or equal to 0, this expression is equal to 0 also okay. Equal to 0 also okay. See here you put x equal to 3 in this. Put x equal to 3. When I put x equal to 3 here, this term will become 0. So this total term will become 0. Right? So x equal to 3 is also solution to this. So what I can write? Union 3. Right? Now, this is the solution. You observe which option is the right option here. See this second option. Closed interval minus 2 to 0, union 3. I hope you understand this, right? We are in 14th problem. By this time, you must understand these things easily. Okay, now we'll move to next problem. You observe this question. This is rational inequality. When rational inequality is there, you make sure the denominator is not equal to 0. You observe these powers you observe here, even number, odd numbers are there like this. Right, let's start solving this solution. Okay, first point, you observe the question. These are all linear factors. Here one problem is there. Linear factor, all are linear factors, but this is not in the form of x minus a. This is not in the form of x minus a. This is in the form of a minus x. But I want x coefficient 1 only. Here x coefficient is minus 1. So what I'll do? In this, I'll take minus common. If I take minus common, this will become like this, x minus a. Now you can see x coefficient 1 is there. So that one step we need to do immediately. Okay, what I'll do? I'll write this problem as it is. Here 1 minus x is there. Na? I'll take minus common and I'll write it as x minus 1. Okay. So just to get into that exact form, x minus I taken common, x minus 2 whole square. Here 1 minus x is there. Na? In that I taken minus common. Okay. Now this x minus 1 minus x will become x minus 1 into x minus 3 whole cube into x minus 4 whole square divided by x plus 1 less than or equal to 0. I hope you understand this step. Right? Now here minus is there. Na? I don't want this minus here. Now, because to convert into wavy form, standard methods are there now. We discussed in earlier classes also. Here, I don't want minus. What I'll do, this complete inequality, both sides I'll multiply with minus 1. You know rules of inequalities. In an inequality, if I multiply with a negative real number, the sign of inequality changes, right? Multiply with minus, minus of minus will become plus, right? So I'll write this as it is. Minus of minus will become plus, and this inequality is there, na? This less than or equal to changes to greater than or equal to. I multiplied both sides with minus 1. See, minus of minus plus, minus 1 into 0 is 0 only. I hope you understand this. Okay. Now you observe all are linear factors and they are in the form of x minus a, x minus b type. Then I can use wavy curve method now. What I'll do, I'll take a number line, equate this to 0. What you will get? X equal to 2. Okay, x equal to 2. Somewhere here you will get x equal to 2. Equate this to 0. You will get x equal to 1. X equal to 1. As per number line order only you need to mark. X minus 3 equal to 0. That means x equal to 3. Okay, x equal to 3. Equate this to 0. You will get x equal to 4. Okay. Equate this to 0. You will get x equal to minus 1. You got like this 1, 2, 3, 4, 5. 5 numbers are there. Okay. Now in the rightmost corner you always keep plus. Now you observe this 4 is coming from where? 4 is coming from this. Here the power of this is even power is there. When even power is there, don't change the sign. Keep it as it is. Okay, keep it as it is. Now this 3 is coming from this. You see its power is odd power is there. If odd power is there, sign changes. Plus changes to minus. You write minus. Okay. Now here plus 2 is there. 2 is coming from this. You see even power is there. When even power is there, sign won't changes. This minus remains minus only. Minus remains minus only. Okay. Now here 1 is there. 1 is coming from this. Right here odd power is there. So sign changes. Minus changes to plus. Now here minus 1 is there. Minus 1 is coming from this. In its power, odd power is there. Only x plus 1. Odd power means sign changes. Plus changes to minus. As it is a rational function, denominator cannot be equal to 0. You see, this x plus 1 cannot be equal to 0. That means x cannot be equal to minus 1. So what I'll do, at minus 1, I'll mark an open circle. That means minus 1 is not a part of the solution. Keep this point in your mind. If I take x equal to minus 1, denominator will become 0. This function is not defined. That's why in rational function, denominator cannot be equal to 0. Okay, right. Right, here now what sign we need to look for? Greater than 0. Greater than 0 means positive sign. Okay, look for positive sign. Here greater than or equal to is there, na? So when greater than or equal to is there, then all these, look here, all these is a part of a solution. I am marking a dark circle here. You try to understand. These are all the dark circles, right? Now, okay, I'll shade greater than 0, na? Greater than 0 means positive sign. Positive sign, positive sign, positive sign, right? You observe this yellow color part is there, na? That is the solution of given inequality. Okay, I'll write this solution. X belongs to open interval minus 1 to closed 1, because 1 is a part of this solution, because here equality is there. Okay, union closed interval 3 to infinity. Here you see this whole thing came including 4. If you put x equal to 4 here, equal to 0, this whole thing will become 0. I hope you are understanding. So you observe the options. Which option is correct option? You see, this is the open interval minus 1 to 1. Okay, you observe the options here. Open interval minus 1. You see this interval, how we read it as? We read it as the interval open minus 1 closed 1. It is there here, right? Union 3 to infinity. So for this, third option is the right option, right? I hope you understand solution to this problem. Now you observe this question. It is a rational function. Rational function means make sure the denominator is not equal to 0. Okay. And you observe these linear factors. All x coefficients are 1 only. These are all linear factors. All x coefficients are 1 only. So directly you can mark this number line. On this number line, you start equating them to 0. You see here, x power 50 is there. Now, this is nothing but x minus 0 whole power 50, right? So, if we equate this, if I equate this to 0, I'll get x equal to 0. Or x equal to 0. Next, I'll equate this to 0. I'll get x equal to 2. Okay, I'll get x equal to 2. Next, I'll equate this to 0. I'll get x equal to 3. Okay, x equal to 3. Next, I'll equate this to 0. I'll get x equal to 1 by 2. 1 by 2. X equal to 1 by 2. Somewhere here you will get 1 by 2. Okay. Next, I'll equate this to 0. I'll get x equal to minus 8. X equal to minus 8. Okay. Equate this to 0. You will get x equal to minus 1. Okay. Equate this to 0. You will get x equal to minus 2. Total here you see 1, 2, 3, 4, 5, 6, 7. 7 numbers you must get. 1, 2, 3, 4, 5, 6, 7. Yes, I marked all these critical values. That means I equated these to 0. Whatever x values I got, those x values I marked on the number line. Now, Wavy curve method says that, and one more thing here, is this rational function, denominator cannot be equal to 0. See, when x equal to 0, denominator is 0. So, in the, you see here, at 0, I'll write open circle. That means 0 cannot be a part of the solution. If x equal to 3, denominator will become 0. So, 3 is not a part of this solution. X cannot be equal to 3, open circle. And x cannot be equal to minus 2. X cannot be equal to minus 2. Okay. Now, Wavy curve method says that in the rightmost corner, you keep a plus. Okay. Now, you observe this 3 is coming from where? This 3 is coming from this, right? Here, its power is odd power is there. When odd power is there, sign changes. That means alternate whatever you will write, there you will change the sign. Plus changes to minus. Here, minus came. Okay. Now, 2 is there. 2 is coming from what? 2 is coming from this. Here, even power is there. When even power is there, sign own changes. So, here minus, you keep it as it is. Now, 1 by 2. 1 by 2 is coming from, 1 by 2 is coming from this, right? Here, what power is there? Odd power is there. When odd power is there, sign changes, right? Sign changes, this minus changes to plus. Okay. Now, this 0. 0 is coming from this. Even power is there. When even power is there, sign own changes. That means again plus comes. Okay. Now, here minus 1 is there. Minus 1 is coming from this. Here odd power is there. 253. Odd power is there. When odd power is there, sign changes. Okay. Now, minus 2. Minus 2 is coming from this. Here odd power is there. When odd power is there, sign changes. That means minus 2 plus. Okay. Next, further, you see here minus 8 is there. Minus 8 is coming from this. Here even power is there. When even power is there, sign own changes. Right. Here plus again. Now, you see what they are asking, greater than 0. Greater than 0. Greater than 0 means we need to look for positive sign. Okay, I'll mark this. Here positive sign is there. Here positive sign is there. Here also positive sign is there. Here positive sign is there. Here positive sign is there. You observe here strictly greater than is there. As strictly greater than is there, these are not a part of the solution. These numbers minus 1, minus 8, these are not part of the solution. Okay, strictly greater than 0 is there. So I'll write this in interval form. X belongs to minus infinity to minus 8. Here strictly greater than is there. So here for minus 8 is not included. Union minus 8 to minus 2 union, you observe here. Here you observe plus sign is there. Union open interval minus 1 to 0 union open interval 3 to infinity. This is the solution of this inequality. See, these problems are easy. Only the thing is, little bit of practice is needed. That's it.
Type 4 in this inequalities. Inequalities involving with quadratic expressions. Inequalities involving with quadratic expressions. Before doing inequalities linked with quadratic expression, you need to know few interesting points in this quadratic equation. Quadratic expression means you know an expression of the form ax square plus bx plus c equal to 0 is the quadratic equation. Quadratic expression means ax square plus bx plus c and a is not equal to 0. Then it is a quadratic expression. Okay. You know discriminant of this. Discriminant of this is what? B square minus 4ac. Here, what point you need to know? Discriminant, that is nothing but b square minus 4ac is less than 0 and a is x square coefficient in that quadratic expression. If a is greater than 0, discriminant is less than 0 and a is greater than 0, then this expression x square plus bx plus c is always positive. Whenever you see quadratic expression, this is positive or negative. It can be positive, it can be negative, depends upon x values. It depends, right? So something like this, man, x square plus x plus 1, 2x square minus x plus 1. This expression can be positive, this expression can be negative, depends upon the x values, correct? If you identified that discriminant is less than 0 and a is greater than 0, then this quadratic expression is always positive. I'll explain this graphically also, but I'll take one example to discuss this. I'll consider one equation x square plus x plus 2. This is a quadratic. For different x values, it gives different values. It can be negative, it can be positive. Here you observe one thing. X square coefficient is what? X square coefficient is 1. What is b square minus 4ac? You calculate here. Discriminant of this b square minus 4ac. This is negative. Discriminant is negative. 4 minus 8 minus 7, it is negative. And what is a? A is x square coefficient. X square coefficient is 1. 1 is greater than 0. So this expression, quadratic expression, satisfies this condition. D is less than 0. A is greater than 0. In this case, this x square plus x plus 2 is always positive. You can check like this. Why it is positive? X square plus x plus 2 is there. Na? This x square plus x is there. Na? This I can write in the square form, like a plus b whole square form. I can write like this. X square is there. Na? That's why here x square is there. Na? X square coefficient 1. So I written here x. When you expand this, you will get x square. What I am trying to write? I am trying to write x square plus x in the form of a plus b whole square. Here this is 2ab term, 2 into x into, by writing what number in 2ab, by writing what number, after multiplying all this I will get x. If I write 1 by 2, this 2 will get cancelled, you will get x. That means what is that b term, a plus b whole square form? Now that b term is 1 by 2. Okay, x plus 1 by 2 whole square minus square of this 1 by 2. Always you write like minus square of this 1 by 2 is 1 by 4. You can just, I am trying to explain why. No need to check like this every time, right? This expression is clearly positive. Why it is positive, I am trying to explain here. When you simplify this, what you will get? You will get x square plus x. You will get x square plus x. If you want, you can check. Expand this. X square plus 1 by 4 plus 2 into x into 1 by 2 minus 1 by 4. You see, plus 1 by 4 minus 1 by 4 will get cancelled. X square plus x, right? What is the extra here? Plus 2. That plus 2 you write. Okay. You simplify this. What you will get? X plus 1 by 2 whole square. Here you observe minus 1 by 4 plus 2. That is what? Minus 1 plus 8 by 4. That is plus 7 by 4. Plus 7 divided by 4. As square is there, this is clearly greater than or equal to 0. And plus 7 by 4. 7 by 4 is positive. This tells you that this expression is clearly greater than 0. This expression is clearly greater than 0. Every time, no need to check like this. Whenever you take quadratic expression ax square plus bx plus c, in that if discriminant is less than 0, a is greater than 0, then this expression is clearly positive. When you know this expression is clearly positive or clearly negative, we can cross multiply. Right? Because in inequalities, we cannot cross multiply very easily. You must know that expression is positive or negative, right? Okay. You see the other case, ax square plus bx plus c, its discriminant is less than 0. In the last two cases also, discriminant is less than 0. If a is negative, that means x square coefficient is negative. In that case, this ax square plus bx plus c is always negative. This also you can check with the help of example. You observe here, I consider one quadratic expression. X square coefficient is what? X square coefficient is minus 1. That is negative. A is negative. Okay. What is discriminant? I will calculate discriminant of this. B square minus 4. A is minus 1. C is minus 2. That is 1 minus 8. That is minus 7. Minus 7 is less than 0. Right? Discriminant is negative. Discriminant is negative. Okay. And a is what? X square coefficient. X square coefficient is minus 1. Minus 1 is negative. So here, whenever a is less than 0 and discriminant is also less than 0, then this expression ax square plus bx plus c is there. Now that is always negative. If you want, you can check by taking this example. Here you see minus x square plus x minus 2 is there. Now you take minus common. Then what this will become? This will become x square minus x plus 2. Now this x square minus x is there, now that I'll write in the form of a minus b whole square, right? If I write this in the form of a minus b whole square, x minus 1 by 2 whole square minus square of this number is 1 by 4. If you simplify this, if you want, you can check. If you simplify this, then you will get x square minus x, right? Plus 2 is there, now that plus 2 you write here. Okay, that equal to minus of x minus 1 by 2 whole square. You simplify this, minus 1 by 4 plus 2, you simplify, what you will get, minus 1 plus 8 by 4, that is plus 7 by 4. Okay, and you observe this, this is clearly positive, right? Here minus sign is there. As minus sign is there, this whole expression will become negative. No need to do like this every time. Whenever you identify the quadratic expression ax square plus bx plus c, you identified that discriminant is less than 0 and x square coefficient is negative. In that case, this expression is always negative. Now we do one problem based on this quadratic inequality. Now I'll try to explain the same concept graphically. You know Desmos app. In that Desmos app, you can check with different examples. You observe here 2x square plus 3x plus 2, right? Here x square coefficient a is positive, b square minus 4ac, if you calculate, b square minus 4ac is negative, right? So b square minus 4ac is negative and a is greater than 0. In that case, this expression is always positive. You observe graph of this. This graph, if you observe, its y values are on positive y axis. If this graph didn't went like this, if it went like this, then its y values are negative, right? At the same way, if you observe this example, x square coefficient is negative, b square minus 4ac is also negative. In that case, this expression is always negative. When you check the graph, this graph comes like this. You see its y values are in the negative y axis. I hope you understand this graphically also. Now we do one problem related to this quadratic expression in inequalities. You observe this question, you need to solve this inequality. Here, you know, when inequality symbol is there, we cannot cross multiply easily unless if you don't know this expression is clearly positive or clearly negative. You observe here x square coefficient is 1, that is greater than 0, and b square minus 4ac you calculate, x square coefficient is 1, that is greater than 0, b square minus 4ac 16, b square minus 4ac. You see, this is negative. As a is greater than 0 and its discriminant is less than 0, then we can say that this expression is clearly positive. This expression x square minus 4x plus 5 is always positive. As you know this is positive, now you can cross multiply this, right? We know that this is clearly positive. So to simplify this, what I'll do, x square minus 5x plus 12 is greater than or equal to, you bring this to this side and multiply with 3. What you will get, 3x square minus 12x plus 15. Now you bring all x square terms, x terms, constant terms at one side, then what you will get, do one thing, you take all these terms to this side. Okay, 0 is greater than 3x square minus x square, 2x square minus 12x plus 5x, that is minus 7x plus 15 minus 12 plus 3. This you can write like this, 2x square minus 7x plus 3 less than 0. Split the middle term, 2x minus 1 into x minus 3 less than 0. Now as per number line order, we can say, so here put x equal to 1 by 2 and x equal to 3. If we equate it to 0, you will get these values. Rightmost corner plus and then alternate symbols. As here less than 0 is there, negative sign. You observe x belongs to open interval 1 by 2 to 3. This is the solution of given inequality. I hope you understand this solution. Now we'll do few PYQs based on these inequalities.